planet Earth, our home. The home that we're still learning so much about. As a matter of fact, we barely know anything about it, specifically about things happening on the inside. As a matter of fact, we know so little about the inside of our planet that every single year we seem to discover something new, something incredible. With some of the recent discoveries from the last few months being in regards to what's known as the large low shear velocity provinces, the very large blobs you see right there in the center of the planet. But now the scientists have discovered something else, something even more unusual. Something that was more or less theoretical up until now. It looks like our planet, somewhere inside it, has these unusual magnetic field waves that seem to be really powerful and seem to propagate through the planet relatively fast. The waves that could in theory explain some of the unusual anomalies we're observing in regards to the magnetic field of planet Earth. Hello wonderful person, this is Anton, and today we're going to be talking about this recent study that just came out and essentially discuss what all of this means, and of course how all of this was discovered as well. And the how part here is really important because, well, it's really due to these advances in technology and various detectors on the planet and even above the planet that we're now able to see inside planet Earth and analyze various structures that were previously invisible to us. Now when it comes to things like these blobs you see, usually all of this is detected through the seismology. Or to be more exact, by detecting different waves coming from, for example, an earthquake, and by measuring the speed of various waves as they pass through different regions of the planet, it becomes possible to literally scan the internal part and discover some unusual anomalies on the inside because the speed here does change depending on the location. But now we also have several satellites orbiting around the planet that are sensitive enough to detect some other features that were previously invisible to a lot of detectors on the planet. And one such mission is the ESA's Swarm. It's essentially 3 different satellites, I guess it's a very small swarm, whose main mission for the past 3 years was a very high precision and high resolution measurement of the strength, direction and variation of the Earth's magnetic field. Or in other words, as they orbit the planet, they provide very precise measurements of various changes in the magnetic lines of the planet. And then using this data to study not just the magnetosphere and the ionosphere, but also the oceans, the Earth's core dynamics, and even various types of magnetic anomalies on the surface of the planet, as well as what effects all of this has on the upper atmosphere of planet Earth. And in the last 9 years of operation, these satellites have already made quite a lot of interesting discoveries. For example, an unusual feature present in the outer core of the planet, a strange jet stream that seems to be responsible for rapidly moving a lot of liquid iron inside the planet, with the speed of the jet being approximately 50 km per year. These satellites were also responsible for finally confirming the unusual Aurora-like phenomenon known as Steve that we're still trying to understand even today. It was only discovered a few years ago. But more importantly, a couple of years ago, these satellites were able to confirm that there is an unusual anomaly somewhere in the South American region where the magnetic field seems to be weakening over time. Now it's still not clear why this is happening, but this recent discovery might be able to provide some answers. And so this mission is actually really important, especially because the magnetic field is crucial to the survival of life on planet Earth. And so obviously understanding the function of the magnetic field, how it sort of changes over time, and how all of these anomalies form is very important as well. But this new multi-year analysis identified something entirely new. Something that we've never seen before and something that was very theoretical and never thought to be so extreme. So it looks like there is a very unusual magnetic wave that seems to move right above the planet's core and takes approximately 7 years to cover the planet once, with the wave being formed by the lines extremely close to the core itself. But I guess what's really interesting is the fact that the scientists always assumed that if these waves were real, they would most likely be much weaker and very likely move extremely slow. But when the scientists combined the data of the Swarm satellite with the German CHAMP mission and the Danish Ørsted mission, while also using some of the geodynamo computer models, they discovered that the magnetic field is definitely not static. It moves around, it changes shape and size, and it has a lot of features we still don't really understand. And as you can see from this graph, it actually took approximately 2 decades of observations to discover this unusual pattern. And so what we're seeing here is what the scientists refer to as the magneto-Coriolis waves. These are huge waves, very likely formed by the magnetic field as it moves around and shifts around very close to the core, with the waves being the strongest at the equator. Their amplitude or their height is estimated to be approximately 3 kilometers. and they seem to be moving westwards at a rate of about 1500 kilometers per year. But the scientists also mentioned that this is the first such wave discovered. They actually assume or theoretically predict that there are going to be other amplitudes and possibly even other waves, maybe even bigger and more profound in scale. So basically this is just the first discovery of these magneto-Coriolis waves and the first confirmation of their existence. Now at the moment it's not entirely clear what produces these waves, but the scientists think that it's very likely due to a lot of disturbances on the inside and possibly due to various features inside the Earth's core, and maybe even because of these unusual blobs you see in this video. But I guess more importantly, these waves could potentially explain some of the anomalies we're observing on the planet, including of course the recently discovered South Atlantic anomaly. So a lot of these anomalies and a lot of the unusual observations from the surface very likely is influenced by the motion of these waves as they move around the planet. In other words, unlike some of the articles from 2020 that even suggested that the magnetic field of planet Earth might be actually flipping because of the detection of this anomaly, the reality is that it's probably produced by these waves and it's probably going to be shifting in the next few years. In other words, none of this is just as simple as things are about to flip. The mechanism behind these waves is much more complicated, and the actual effects on our planet are still not truly understood. But because of this discovery, we now potentially have a new technique and a new way for us to measure things inside the planet. In the same way that the seismological waves allow us to measure the structures that you see here, these magnetic waves can now allow us to measure things inside the core, or possibly even help us see things we couldn't see before. Specifically things on the boundary between the outer core and the mantle, and some of the things on the surface of the core as well. So these waves, officially known as the magneto-Coriolis eigenmodes, also known as MCE, are actually just the beginning of the exciting discoveries about the internal structure of our planet, which means that we're going to be hearing more about this in some of the future videos in the next few years. Which also means that you should probably subscribe, because we'll be talking about this in the future. And this will also very likely lead to more explanations about how the magnetic field functions, how it changes over time, and very likely explain many anomalies we're seeing on the surface of our planet, but also surfaces of other objects in the solar system as well. Because it's very likely that many objects, including objects like Jupiter and Saturn, have these as well, and they're very likely much more powerful. So some of the anomalies could be formed because of these waves. But I guess for now that's pretty much all we know. We know they exist, we know they seem to be important, and we also know that they seem to be powerful, and there could be a lot more waves that we haven't discovered just yet. So today, the scientists, or actually anyone on the planet, still has no clear idea if any kind of extraterrestrial life exists out there. We obviously have a lot of propositions, we have a lot of speculations, and even a lot of studies focusing on what we can maybe look for to find some kind of alien life. But as it is right now, everything out there kind of looks like this. It kind of looks more or less empty. And more specifically, the extraterrestrial intelligent life, the signals from which we've been looking for several decades now, has never really been found anywhere, with all of the potential signals so far explained in some other way. And that of course includes the most iconic wolf signal that we discussed in one of the previous videos. And so at the moment, unfortunately, it's looking more and more like we might be the only species out there. The only intelligent species able to self-reflect and able to create technology to help us with daily lives. But there's still some hope. Hello wonderful person, this is Anton, and today we're going to be discussing a relatively important paper that unfortunately I did not get to cover before, that I really wanted to talk about because I've actually personally been thinking about this idea for a pretty long time. The idea that in order for us to actually maybe think about extraterrestrial intelligence or possibly find something out there, instead of focusing too much on the out there and searching for life on other planets, we should maybe first try to find something in the historical record of planet Earth. Because by discovering some kind of signs of previous intelligent life on our planet that naturally evolved from life that existed here, we might start to speculate about the existence of similar life somewhere out there in the rest of the galaxy. And there's a really important reason for this particular idea. As I study astrobiology more and more, I realize that it's actually exceptionally difficult for life to form in the way we believe it formed here on planet Earth. Even simple bacterial life, the one we find pretty much everywhere on Earth, might have not really had the same luck elsewhere. And developing multicellular or even more complex macro life is even more difficult. So making assumptions that this exists elsewhere on other planets is actually currently kind of incorrect. Sometimes this is also referred to as the rare earth hypothesis, but we'll discuss this in another video sometimes in the future, so make sure to subscribe. But all of the recent studies kind of really indicate that the actual process of creating complex life on the planet just kind of got really lucky with a lot of really complex steps that would probably not occur elsewhere. But it doesn't mean we should stop looking. As a matter of fact, it's maybe even more reason to look harder. And one of the better ways to look for potential extraterrestrial intelligent life is to kind of start connecting all of this from the evolutionary perspective. So for example, when it comes to evolution, we know that things that are kind of more or less successful tend to evolve independently of anything else. I've actually covered a similar concept in one of the previous videos, you can find in the description, but we know that for some unknown reason, nature tends to prefer crabs. The idea of a crab, or morphological crab, has evolved on the planet several times in the last few hundreds of millions of years. In other words, for some unknown reason, this right here seems to be kind of successful. So when we talk about crabs, we don't just actually talk about one species. In reality, this particular morphology applies to a lot of different species. So for example, this kind of a crab that you see is kind of different in terms of a lot of components, including genetics, from, for example, a hermit crab. It just so happens that for some reason, nature tends to re-evolve crabs over and over. Similarly, we know that the idea of flight evolved independently several times as well. And this of course includes the idea of wings. They seem to exist in, for example, insects, they also exist in reptiles, they also exist in birds. So this also seems to be an evolutionary advantage that repeats itself many times. And more recently, there was actually a study from just a few days ago where the scientists discovered that, well, the idea of slime, or the stuff that snails have, but also the stuff that's in our mouth, so basically our saliva, is also exceptionally successful in terms of evolution. A lot of different species, including mammals, independently evolved all kinds of different slime because it just seems to work so well on the planet and it seems to serve so many different purposes. Okay, but what does any of this have to do with what we're talking about, alien intelligence? Well, using similar concepts here, just like, for example, crabs seem to be successful evolutionary, we can kind of make an assumption that complex brains, and by extension complex intelligence, should also be somewhat common in terms of evolutionary success. And assuming that it's evolutionary preferential, or basically that evolves many times throughout the history of the planet, we can then make a conjecture that it should exist somewhere out there where life exists on other planets. Okay, just to rephrase this, if we truly believe that extraterrestrial intelligence exists out there, and that it kind of evolved in the same way that it evolved here on planet Earth, it's pretty safe to assume that it might have evolved several times on the planet, because we're making an assumption here that this is an evolutionary advantage. That all planets that potentially have life on them are going to end up with some kind of a species that's going to become super intelligent and that's going to be self-aware, able to use technology, and essentially kind of communicate in the same way that we communicate using, for example, radio waves. Now, to me personally, as a side note, that's a lot of assumptions we're making here, but that's kind of what a lot of modern astrobiology, and specifically astrobiology pertaining to extraterrestrial intelligence, is based on. And that of course means that if we look in the historical record of our planet, we actually should be finding more signs of intelligent life existing in the past. And this hypothesis was officially proposed only a few years ago, back in 2017, and it currently has an intriguing name. It's known as the Silurian hypothesis. Now, this is actually a bit of a play on words. It's actually based on the episode of Doctor Who that had a strange race known as Silurians that evolved millions and millions of years ago from ancient reptiles that also possess intelligence, but then because of the climatic changes on the planet, essentially went into a prolonged state of hibernation in order to survive the inhospitable Earth, waking up on modern Earth and then interacting with the Doctor. And so because of this episode, the scientists behind this paper decided to give it a kind of a tongue-in-cheek name, calling it the Silurian hypothesis, which by itself comes from a geological period roughly around 440 million years ago. And honestly, for me personally, this right here represents one of the more important papers, or one of the more important propositions, when it comes to the idea of extraterrestrial intelligence. Because at the moment there's really only two possible answers. Either we're completely alone and we kind of evolved completely by accident, and there's really no other intelligence anywhere out there, which makes it a kind of an evolutionary fluke, and it's unlikely to repeat anywhere or anywhen in the universe, or extraterrestrial intelligence and any kind of intelligence is pretty common, and we should be finding a lot of it here on planet Earth in the historical record. Although obviously this is not a new idea, and even that Doctor Who episode was not the first time this was ever proposed. There's actually at least one other science fiction book from the 50s written by Alice Mary Norton, who used to write under Andre Norton's pseudonym, who talked about a relatively similar concept in the Time Traders. Although the idea here was a little bit different. Here the author explained that pretty much all of the signs of modern civilization are going to be completely erased by the time the next glacial period begins. In other words, everything you see around you, all of the cities, all of the technology, every major building, every major structure we've ever built, will basically be gone. There will be no signs of it left, and within just a few million years, there will be no one to tell the story. And that's of course not really far from the truth. As a matter of fact, that's exactly what the scientists in this hypothesis propose and explain as well. And that's of course why it makes it so difficult to either prove or disprove this. We currently have no idea if any of this is correct. Here I actually wanted to show you this beautiful illustration by one of the authors. We basically have no idea if back in the day, when the dinosaurs were around, they also had some kind of a super intelligent species that would drive their own versions of cars, have their own versions of smartphones, and eventually result in their own demise over time. All of this would be gone to history because of the way that geology works on our planet. But in this paper, the scientists decided to actually work out any potential ideas or experiments we can conduct on the planet to try to find out if this actually existed and if it was possible in the past. So just to clarify, they're not saying it did exist or it did not exist, they're just saying it's about time we started thinking about potential experiments where we can maybe explore this more scientifically. With one of the, I guess, stranger or slightly scarier conclusions proposed by the scientists in the study is that a lot of the signs we see in the geological history of the planet kind of resemble what we're now observing in the Anthropocene, the period when humans started to dominate the globe, or basically how the modern climate change to some extent actually resembles a lot of sudden changes that did happen in the last few millions of years. With one specific type of an event currently still unexplained by scientists, often referred to as hyperthermals. The sudden increase in temperature that usually lasts for a few thousand years, but happens in a very short period of time and currently doesn't have a very definitive explanation. With one very well-known example we explored in the past in one of the videos, should be in the description, known as PETM, Paleocene-Eocene Thermal Maximum. The event that happened approximately 55 million years ago, when the global temperature suddenly increased by 5 to 8 degrees Celsius or 9 to 14 degrees Fahrenheit, just to then drop suddenly within a few thousand years. And there's been quite a lot of explanations for what might have happened. Maybe an asteroid collision that released huge amounts of CO2 gas or a lot of other gases that usually warm up the planet. Maybe volcanic eruptions doing the same. But at the moment there is just not enough clear evidence, specifically craters or any volcanoes that were produced during this time, to suggest any specific explanation. On the other hand, all of these observations kind of resemble what's happening to the planet right now as well. And so trying to figure out exactly what caused these warming conditions is one of the potential ways we could start assessing the hypothesis and try to answer these somewhat difficult questions. Also likewise, any kind of elevating industrial civilization should maybe produce very similar effects on their planet as well. At least that's what the modern science expects. But what are some of the questions we can ask ourselves in regards to the history of our planet in order to see how viable the hypothesis is? Well, first of all, generally speaking, the geological record of our planet is usually very incomplete, and it becomes even more difficult to study it as you go back in time. For example, today we know that only about 3% of the entire surface of the planet has any kind of urban activity on the surface, or basically anything that would potentially resemble modern technology. And so the chance for a lot of these cities to survive for thousands or even millions of years is exceptionally low. Which also means that within just a few thousand years, the chance for discovering these technofossils for some future humans living here is also going to be pretty low as well. You can kind of see that there are some bottles here and a lot of other leftovers, but all of this is going to disappear in time, turning into nothing but almost completely indistinguishable sediment. And for any major city to leave any mark inside the sediment, it really depends on where it's located. If it's located on the subsiding plate, it might eventually become sediment and get locked inside rock, leaving behind certain marks. But if it's on the rising plate, or if it's somewhere in the middle, everything here might eventually be eroded with time by different types of rain and wind, especially as the rain becomes more acidic, leaving pretty much nothing behind. On the other hand, when it comes to things like, for example, dinosaur fossils, we usually discover one fossil for every 10,000 years, with the footprints of dinosaurs being even more rare. But even though humans have been on the planet for at least 300,000 years, the civilization that we're used to has only been around for just over a few hundred years, technically even less than that. And so the chance for something from our modern civilization to turn into a fossil that can be discovered in the future is actually super low. And so right now there's a really big chance that after a few million years, everything we take for granted is going to look like this. And so the natural question here is, how do you then tell if any intelligent species ever existed on the planet like we do right now? Well, we might be able to distinguish certain sedimentary anomalies even present in the sediment today, and then combine this with observations of various hyperthermals or any other major changes in the temperature that don't seem to have any other explanation. For example, all of the technofossils are going to leave behind a very specific isotopic ratio that's extremely difficult to find in nature, including of course residues of carbon that doesn't exist in nature, such as various microplastics. These should linger for quite a while. There should also be a geological record of a major extinction event that doesn't really have any good explanations. Also, signs of unusual chemicals that are generally not produced in nature either. For example, things like CFCs, or more specifically, various types of transuranic isotopes from nuclear fission, which are obviously all of the chemical signs we're currently living on the planet by doing our regular stuff, by being ourselves. And so we kind of expect something similar could have happened in the past. There could have been another species that was basically exploiting the planet and, as a result, left some signs of this in the geological record. But that's of course assuming that any civilization is going to have a lot of very specific needs in terms of energy. And a lot of civilizations are going to eventually result in similar types of pollution. Naturally, a pretty big assumption. But it's really the only assumption we have right now in order to figure out if this hypothesis has any merit. But even here, there's still a major problem. If this type of a civilization has not existed for longer than, let's just say, a few hundred years, the chance for it to even leave any kind of a mark, and that includes the fossil mark, is still pretty low. And even things like microplastics or things like transuranium elements might have already mixed with a lot of other stuff or disappeared completely, especially if this happened a long time ago. And so if these ancient civilizations ever existed, and if they managed to somehow change the planet in the past, the signs of their existence would still be extremely difficult to discover, with the only signs left after millions of years really just being various types of isotopes that could still be out there in the sediments on the planet. But the scientists in this paper also propose some other ideas that we can kind of learn from ourselves and from the way that we change the planet. So for example, we know that humans also got really good at the idea of geoengineering, changing the environment of the planet by, for example, redirecting water. So for example, detecting various deposits from ancient rivers or ancient lakes that should not exist naturally. We know that something like this is going to exist in the future because of the dams that we have. We also know that the widespread use of fertilizers and huge amounts of agricultural activity is going to leave behind a very specific mark in terms of the excess of nitrogen that should not be possible naturally. And a lot of other manufacturing and industries are going to leave behind a mark in terms of heavy metals and things like rare earth minerals that will suddenly be deposited in a single layer as opposed to being widely distributed as they usually are. These would be very specific tracers that would be a telltale sign that something unusual is happening somewhere in the sediment. And so if suddenly somewhere in the sediment we do find signs of this all happening all at once, it will be a pretty good sign that something was going on in that particular period. At the moment there's really no sign of any of this, but also because it hasn't really been studied thoroughly yet, and also because detecting some of the stuff is still pretty difficult. Hello InfoPerson, this is Anton, and today we're going to be discussing some of the new discoveries in regards to various effects our planet receives as it orbits around the galaxy. Or actually one very specific and somewhat unexpected discovery that came from the recent study, which suggests that the motion of continents on the planet to some extent is actually influenced by the gravitational interactions as the solar system moves to the rest of the galaxy, with all of this related to the concept known as the galactic year. But all of this being a bit of a surprise when the scientists discovered it. But let's discuss this in a little bit more detail because there's quite a lot to unpack here. First of all, when it comes to various periodicities or various patterns on the planet, there are quite a lot of different periods that planet Earth goes through that do influence the geology or even the climate of the planet. For example, in this case, you're looking at something known as precession. Although what effects precession potentially has on the planet is still not entirely clear today. And there are actually quite a lot of different periodicities mostly because of the way that the planet orbits around the Sun that we usually refer to as the Milankovitch cycles, with these cycles resulting in variations of the climate on the planet, which tends to oscillate back and forth depending on where the planet is. There are also a lot of other effects even from the Sun itself, especially as the Sun goes through various cycles inside of it. But for the majority of these cycles, the human lifespan is just too short to notice. As a matter of fact, we don't really notice most of these cycles unless we look at the geological record of planet Earth. But when it comes to the most influential events that basically change the planet dramatically, there are usually two that come to mind. Huge volcanic eruptions that influenced the planet in the past, or massive asteroid collisions which generally influence the planet almost right away. And not so long ago, we've actually discussed this really interesting study that discovered an intriguing link between meteorite impacts and the production of continents on planet Earth, with the implication being that the asteroid impacts very likely influenced the formation of early continents on the planet by essentially softening up some of the crust on early Earth and eventually forcing the continents to form. You can learn a little bit more about this in one of the videos in the description. But this time, the scientists behind the recent study that you can find in the description below as well, identified another previously unknown cycle, but at much grander scales. So this paper right here discovered a cycle that's in millions of years, actually close to 200 million per cycle. And in this case, related to the way that the solar system orbits around the galaxy itself. So what exactly did the scientists find and how did they discover it? In order to find this, once again, they had to study the rocks on the planet. By looking at various minerals, although probably not in the way that this guy is doing it right here, actually by trying to find various types of crystals that generally trap a lot of other elements, and by using uranium dating in order to determine the age, the scientists were able to create a kind of an age and composition graph that showed them how frequent various minerals were molten and how often the crust solidified on the planet, allowing the scientists to see that there's a kind of a frequency in crust production. Or in other words, that the crust on the planet will be produced much more frequently at certain times, and then there would be a kind of a period where it wouldn't be as often. Although in this particular case, this was only using some of the more ancient rocks, so this only seems to apply to the ancient periods on the planet. It would be difficult to see if this is still happening today as well. And the frequency in this case was roughly around 200 million years. So basically every 200 million years, for some reason, the amount of crust on the planet seems to kind of increase, as if the planet suddenly becomes more active, potentially because of volcanism, maybe because of the asteroid collisions, or maybe both. And I guess normally we would probably leave it at that, but in this case the scientists decided to kind of speculate a little bit more and potentially even discover the source of this periodicity. What's causing this? Why exactly is it 200 million years? And so in this case the scientists really have to start thinking outside of the box. They had to leave the solar system and look at the bigger picture. They had to see if any of this could be caused, in this case the orbit of the solar system around the galaxy. Now today we believe that the Sun sort of orbits in this way. The speed of the Sun going around the galaxy is around 240 km per second, and it takes roughly around 200 million years to complete a single orbit. Today this is known as the galactic year. By the way, there's an older video on the channel that should be in the description that actually talks a little bit more about exactly how the solar system orbits around the galaxy, because there are still a lot of misconceptions about it. But anyway, the thing about the solar system as it orbits around the galaxy is that its speed is actually a little bit different compared to some of the other objects, such as the galactic arms. In this case, the galactic arms have a slightly slower velocity of about 220 km per second, which suggests that once in a while, the solar system is going to pass through the galactic arms and thus find itself in a more dense environment with more stars, more gas, and thus more gravitational influence. In this case, the scientists calculate that approximately every 200 million years, the Sun actually passes through one of these galactic arms, experiencing the effects in the process. And by passing through these denser regions, the galactic interaction with other objects, for example some of the stars that could be much closer now, would cause some of the distant objects from the Oort cloud to then make their way toward the inner solar system and increase the collision chance with various planets, including of course planet Earth. Or in other words, by passing through these galactic arms, the chance of a collision with the planet increases dramatically, resulting in major craters, but also resulting in a lot of crust, remelting and reforming again. And because a lot of these distant objects would actually be colliding with the planet at much higher velocities, up to 50 km per second, the resulting collision would be much more powerful compared to a typical asteroid. And so it's these very high energy impacts, periodic high energy impacts, that seem to be visible in the record found in these minerals. Although at the moment, that's just one of the potential explanations. Pretty good one, but still not a definitive explanation, because first of all, we're still not entirely certain how many arms our galaxy has, and how often the solar system actually passes through these arms. And more importantly, we still have no idea what happens to the solar system when it does pass through these arms, and if it actually has any effect at all. Nevertheless, intriguingly, this image created by the scientists also kind of maps the location of the solar system when some of the impacts occurred on the planet. For example, when the biggest crater was created on Earth, the scientists believed the solar system was somewhere right here, whereas the solar system was right here during the impact that killed the dinosaurs, with the stars in this case also indicating the major extinction events. And at least two may have happened when the solar system was indeed in one of the arms. Now, obviously this is a huge speculation and just a correlation, but it would still be interesting to investigate this and to either disprove this or maybe find some other clues in, for example, various asteroids around the solar system, or even by looking at the objects like the moon. For example, by measuring the frequency of collisions on the moon and by essentially counting the craters on the moon, it might be possible to prove or disprove this, because we'd actually expect the same pattern here as well. There should be some kind of a frequency increase every 200 million years. It hasn't been done yet, but this is one way we can maybe prove this. But because the Moon and Mercury have quite a lot of craters on the surface, it would probably take some time to establish this. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries in regards to these relatively large blobs you see right here, present inside our planet. The blobs we sometimes refer to as LLSVP, Large Low Shear Velocity Provinces. And they're called that because, well, there's sort of a mystery. Basically, inside our planet, somewhere right above the central core, or somewhere inside the mantle, there are several blobs, really large blobs, that seem to possess different density as if they were different objects inside our planet, representing approximately 6% of the entire volume of planet Earth. With all of this discovered many decades ago by studying various types of S-waves or shear waves, usually caused by various types of earthquakes as they pass through our planet, and as their speed changes according to what's inside the mantle and according to what's inside the core. And through these various investigations and studies, the scientists over time were able to map these structures, discovering that, well, first of all, they are pretty big, but they also seem to be mostly contained in two separate regions of the planet. There is the African LLSVP, that you can sort of see stretches across most of the Western and Central Africa, and then there is the Pacific LLSVP, that goes through most of the Southern Pacific. With the new study also discovering that there is a major difference between the two, which potentially suggests different origins as well. But first of all, when they were originally discovered, it was sort of assumed that maybe these are just very massive super plumes. Basically, these really large formations formed by the interaction of the outer core with the mantle itself, possibly produced in a very similar way to what we usually see inside a typical lava lamp. But the plumes produced in a typical lava lamp, and by extension planet Earth, would actually be very different in shape according to various simulations. As a matter of fact, we sort of expect very long, very narrow plumes, as opposed to the shapes observed inside planet Earth. And so it's actually more likely that this has slightly different origin and is very likely something to do with objects or things coming from the surface of the planet. As a matter of fact, as you can see on this map right here, each of the LLSVP structures contains several different superplumes or hotspots on the inside, with the plume itself being several thousand kilometers across and being at least 1500 kilometers in height. So it's very unlikely to be just a simple plume that you see right here. And so one of the other more likely explanations actually involved the motion of plate tectonics on the planet, and specifically the subduction of various continental and potentially oceanic plates. For example, we know that once in a while our planet has a tendency to produce what's known as supercontinents, with a lot of these supercontinents formed when many of these plates sort of stick together. But when a lot of different plates come together and start interacting, they can often produce what's known as the slab graveyard, Or basically when a lot of plates suddenly converge in a single area, something that we think might have happened approximately 750 million years ago during the existence of supercontinent known as Rodinia. This could hypothetically result in the accumulation of various oceanic slabs all in a single area. And although the high temperatures and pressures would melt some of these slabs, overall this would produce a heavier and denser area compared to the rest of the mantle. Or in other words, all of this could be just extremely old crust from ancient planet Earth, melted and sort of stuck on the bottom of the planet. But there are, I guess, two problems with this particular explanation. One is coming from this recent paper that discovered that there seems to be a relatively major difference between the Pacific and African LLSVP. And the other one is really in regards to the fact that there are two major spots and they both seem to be relatively massive and relatively large in size. But I guess first let's talk about these major differences. And so this new analysis using various geodynamic models discovered that first of all, these two regions seem to have relatively different heights. As a matter of fact, the African LLSVP seems to be at least twice as high as the one in the Pacific. Here, the African one seems to be at least 1,000 kilometers higher, which the authors think is most likely caused by the slightly lesser density compared to the Pacific counterpart. In other words, it sort of suggests that these two blobs potentially have slightly different or actually very different composition, which may also suggest possibly different origins. They might not have actually been created in the same way. And on top of this, the African LLSVP seems to be a little bit less stable, which the authors believe might explain why there's a lot more intense volcanism in the regions around the African LLSVP compared to the regions in the Pacific, which then most likely affects how the continents move on the surface of the planet right now. But I guess the other $1 million question here is, so what is that other origin story? How did the other LLSVP come to be? Well, it's in regards to that other study we've discussed in a video a few years ago that very likely explains the origin of at least one of these blobs very well. And in this case, it's the story of the formation of the moon. We of course refer to this as the giant impact hypothesis. The idea that approximately 4.5 billion years ago, a relatively large object similar in size to Mars, that we currently refer to as Theia, collided with the early planet Earth, eventually forming the modern planet Earth and of course the moon that we have in our night skies. But it's believed that some of the leftovers from Theia might have actually sunk to the bottom of the planet, probably staying somewhere above the core, forming at least one of these unusual regions. And the fact that it sunk to the bottom and the fact that the density here seems to be different suggests that the fragments from Theia were probably enriched in what's known as iron oxide compared to the rest of the Earth's mantle. And all of this right now seems to match with at least some of the samples we have from the moon and some of the samples from various oceanic islands that seem to be overlying the Pacific LLSVP, which of course suggests that maybe at least one of these, and possibly the Pacific one, was actually created through the giant impact. But the other part, the African LLSVP, might have been created differently, in this case, possibly through the massive amount of subduction during an era of a supercontinent on the planet. But even now, it's still just a hypothesis based on some of the observations and studies we've been doing for the past few decades. So even now, nobody actually knows the true origin of LLSVPs inside our planet, and more importantly, what effects they have on our planet even right now. Hello wonderful person, this is Anton, and today we're going to be discussing yet another unusual discovery coming from within our own planet. And more specifically, a discovery from within the core itself. The discovery from the center of planet Earth. The discovery of something that's happening in the inner core, suggesting that the core of planet Earth seems to be oscillating with a period of approximately 6 years, give or take a few months. And that's something that some scientists have actually speculated about in the past, but because of this new study and new data coming from a very interesting source from the 60s and the 70s, this now becomes a very solid theory. But let's actually start with the data, because the source itself is extremely interesting and what got me personally really intrigued by the story and by the study itself. It didn't come from the usual source. It did not come from earthquakes, which are normally used to study the internal structure of our own planet. And in case you didn't know, The idea here is really simple. By listening to the propagation of various waves and measuring their speed with various seismographs across the planet, it becomes possible to actually determine what's inside the planet and even how fast things are moving or what sort of composition it might have. And because there are so many different seismographs on the planet today, it allows the scientists to create the image of the internal structure of the planet with quite a high resolution. And this has been obviously going on for quite a few decades now, allowing us to discover a lot of different exciting things about our planet, including these unusual structures known as LLSVPs we've discussed in some of the previous videos you can find somewhere in the description. But in this case, the scientists relied on something slightly different. Well, actually, very different. Let me give you a bit of a hint. That's right, nuclear tests. The variety of ground nuclear tests conducted for several decades, starting I guess with the creation of the first nuclear bomb. And more specifically, the Soviet tests from between 1971 and 1974 on the island you see right here, but also very similar US tests on the Amchitka island located in Alaska, with some of these tests conducted slightly earlier in 1969 and 1971. And so by using various types of waves generated by these nuclear explosions in the 60s and the 70s, and by using the data generated in a very similar way to earthquakes, the scientists once again were able to measure the compression waves generated by all of this activity, discovering some new things about the inner core of our own planet. And specifically discovering that the core itself seems to have changed its rotation of spin between 1969 and 1974. Now, what exactly do I mean by this? I don't mean that it reversed its spin. What I mean is that it actually spun a little bit faster and then a little bit slower. And that's actually something that the scientists sort of knew for a pretty long time. It's always been suspected that the inner core of our planet spins slightly faster than everything else on the planet. Specifically, it was believed to be approximately 1 degree per year, meaning that after 360 years, it would go around the planet once. And this is something that was actually published and originally discovered back in 1996. But the calculations from other scientists suggested that it was actually much slower. Specifically, it was probably 10 times slower, meaning that it was about 0.1 degrees per year. And so by using the data from these nuclear tests, they were able to definitively calculate that for some time, the core itself was spinning slightly faster than the planet, but then during some other years, it was spinning slightly slower. In other words, it was kind of oscillating. Every few years, it would either accelerate or decelerate its rotation, with the period of oscillation being roughly around 6 years. And also obviously suggesting that the core doesn't spin at the same velocity. It does seem to change the velocity, possibly due to some features we don't really understand yet. But because the core and the mantle are connected to one another, and because there's also gravitational influence from both of them, this very likely affects the rest of the planet, creating the oscillations here as well. And this is really interesting because not so long ago, we had this other discovery that there seemed to be unusual magnetic waves with a circulation of about 7 years. The video for this is in the description or somewhere right there. And so there might be a chance that two of these phenomena could be somehow related, because at the moment, the magnetic phenomenon is not really truly understood, and so for all we know, the inner core oscillation is responsible for all of this to begin with. Although here, the data is still quite limited. It's really only based on those observations from the nuclear tests, and because there are no nuclear tests conducted anymore, and also because the super powerful seismic detector known as the Montana Large Aperture Seismic Array closed back in 1978, it's going to be impossible to get as much accurate data as it was possible back in the days. This was so powerful that it was able to hear every nuclear test on the other side of the planet. And because nuclear explosions produced relatively clear waves and would actually be very easily observed from various locations, it produced the best possible data for all of this. Earthquakes in comparison are not as accurate and produce a lot of imprecise data that's not as useful for this type of measurement. But the other interesting confirmation is in regards to the length of the day on planet Earth. Because of this unusual oscillation, it looks like the length of the day seems to change by about 0.2 seconds every 6 years. We've actually discussed how the length of the day on the planet changes with time in one of the previous videos, a video that should be somewhere in the description or somewhere right there. And it also seems to have an effect on the geomagnetic field of the planet as well. The field also oscillates with a relatively similar period of about 6 years. And all of this seems to be caused by the shift in that inner core. It moves approximately a few kilometers underneath us every 6 years or so. But obviously nobody really knows right now why it's doing so or more importantly, if it has any other dramatic effects that we're not familiar with just yet. Hello wonderful person, this is Anton, and today we're going to be discussing water, or actually the origin of water here on planet Earth. And specifically we're talking about a new study that seems to have uncovered another potential source from which water might have come. A somewhat unlikely source, as a matter of fact. That source being our sun itself. So the study that, as always, you can find in the description below, presents a pretty strong argument that at least some of the water might have actually come from the sun. And that of course needs a bit of an explanation because, as you probably know, sun is mostly made out of hydrogen. But to start, let's discuss the idea of the origin of water still being a bit of a mystery. Now, for many years, for many decades, the scientists thought that maybe it came from various asteroids and various comets. As a matter of fact, comets were the primary assumed source simply because of the amount of water present on their surface and inside of them. But then we got to visit some of these comets, including the famous 67P comet, and during their Rosetta mission, the scientists have discovered that the water present here was a little bit different. It wasn't the same water as what we have on planet Earth. And to be more exact, it was the difference in the isotope composition of water itself. So here on Earth, water generally has 3 very specific isotopes in a very specific ratio that's only present here on planet Earth. And that's in terms of mass. In reality, you actually have 6 different isotopes based on how heavy the oxygen and how heavy the hydrogen are as well. But investigating comets, the scientists discovered a completely different ratio there. Which of course suggested to the scientists that it's most likely that some of the water came from somewhere else, or possibly even most of the water on Earth was not from comets. Now the next obvious explanation would be asteroids and cosmic dust, but to date only in some of the asteroids the isotopes sort of matched, but unfortunately there are just not enough of them around to explain the amount of water on planet Earth. And the asteroids we usually refer to as the carbonaceous chondrites seem to match the best. But these represent only roughly around 5% of all of the asteroids that fall on our planet, so the numbers here just don't add up. Something other than asteroids should also be producing some of the other water, possibly even most of it. Now, one of the bigger explanations from a few years ago did not look for the solution in outer space. It actually looked for the solution inside the planet. And this explanation, or this proposition that you can watch in one of the older videos, suggested that a lot of the water probably came from within the planet, from the minerals that already had water when the planet was just created. For example, one of these minerals that's well known to actually have a lot of water on the inside is the mineral located approximately 1,000 kilometers underneath the surface of planet Earth, and it's known as ringwoodite. But unfortunately, these propositions are somewhat difficult to prove, mostly because we can't just go inside the planet and measure how much water is potentially stored there. And so even though the explanation was quite unique and also explained the potential origin of water, it was almost impossible to scientifically prove this, unless of course we find a way to study ringwoodite in its natural setting and see how much water it stores on, for example, some other planet or in some other environment. So far this hasn't really been possible, and most of the ringwoodite is usually studied in a very limited lab situation. And so without knowing the exact composition of isotopes inside the planet itself, it would be basically impossible for us to prove this idea. Okay, well now we seem to have another proposition, and this proposition takes us back to outer space, with the main origin of all of this being the solar wind itself, the extremely charged particles that come from the sun and essentially represent tiny hydrogen molecules, with the origin of this water being the solar wind. The wind itself, of course, composed of various charged hydrogen particles. But this is not a new proposition at all. This paper from 2012 was already able to show that certain types of hydrogen ions can actually react with various rocks, various silicate minerals, which would then result in the production of tiny amounts of water on the surface and even inside of the silicates. But in this case, the recent paper proposes that a lot of the solar wind in this case could actually interact with tiny dust particles and also tiny asteroids and possibly even big asteroids, producing various amounts of water on their surface. But more specifically, it proposes that a lot of water can be formed in a lot of other types of asteroids that haven't really been studied to date very thoroughly just yet. In other words, they suggest that it's not just carbonaceous chondrites that could deliver water, it's also cosmic dust and potentially some other types of asteroids that have generally been believed to be water-free, but in reality they might have contained water somewhere on their surface or somewhere else inside of them that has actually not been detected. And in this particular case, they focused on the studies of samples taken from this beautiful asteroid known as Itokawa, the samples that were returned to Earth back in 2011 by JAXA, the Japanese space agency. And this was of course the first asteroid retrieval mission that was also known as Hayabusa, but this was Hayabusa 1. Very recently Japan also succeeded with the Hayabusa 2 mission. But this here is what's known as an S-type asteroid. Asteroids that are known to be relatively high in density and contain mostly just simple rocks. And so the scientists in the study wanted to see if this asteroid could also be a potential source of certain types of water, but specifically they wanted to investigate the samples for the presence of water right on the surface of these samples that would be similar to the composition of the solar wind itself. Specifically, they were really looking for the isotopes of hydrogen. Here they used a very rigorous technique known as atom probe tomography. It's essentially a technique developed back in 1967 where an extremely precise measurements of each individual atoms can actually provide extremely accurate composition of a certain sample and even create a three-dimensional image of what happens inside the sample as well. And so by applying this technique to the samples from the asteroid, they've discovered that the surface of these samples contain various water and hydroxide molecules, with most of the enrichment being on the surface itself, suggesting that it was most likely created by a lot of hydrogen coming from the sun itself, which, by bombarding the asteroid over billions of years, very likely inserted a lot of these molecules relatively deep inside the surface, which then turned into water that stayed there for a long time. But more importantly, all of this was discovered at just the right depth where the scientists theoretically predicted all of this to exist. And because in this case this water was much lighter in terms of its mass, it was a lighter isotope, this very likely added to the total content of water on planet Earth along with some of the other sources. In other words, the water in these asteroids was very likely just an additional source, it wasn't really the entire source. But because it would also be present in a lot of different particles such as cosmic dust and a lot of smaller particles hitting our planet pretty much every second, given billions of years, this would add up to a relatively large content of water accumulating on the surface of Earth. And the study also suggests that in a typical S-type asteroid, it would actually contain approximately 20 liters of water for every cubic meter of rock, which, based on the total mass of the asteroids in the solar system, may explain where some of the or a lot of the water on Earth possibly came from. But this also explains something else about the water in other locations, for example, the moon. One of the bigger mysteries in the last few decades was the discovery of a lot of water deposits on the surface of the moon in various locations where it was believed to not exist. And so this would be an explanation for how a lot of this water could also be produced on the moon, which means that future explorations of the moon could maybe use this to extract some of the water. On top of this, because some of this water is produced underneath the top layer, it's actually protected from a lot of other elements, and so it can remain inside these rocks for a pretty long time, which makes some of these asteroids a potential source of future water for example, when we start traveling across the solar system or possibly even between stars. For example, some of the space missions in the future could maybe harvest the cosmic dust and smaller asteroids and then extract water from within them. Which of course means that in some of the future missions, maybe the astronauts wouldn't even have to bring that much water with them. They can just harvest it directly from space itself. And this would also be the case for the surface of the moon. If we can find a way to extract the water from here, we'll be able to create a functioning colony. But this also means that maybe some of the other stars that produce even more solar wind could maybe produce more water. Now that's something that we're not going to know until future studies and until very thorough investigations of other planets and other star systems, but it's a really interesting proposition. For example, in the TRAPPIST-1 system, all of the planets and of course all of the asteroids here are bombarded with way more solar wind coming from the parent star. And this could mean maybe more water. Or at least based on the study and based on our understanding of how hydrogen ions can potentially form water molecules. Hello wonderful person, this is Anton, and today we're going to be talking about some of the major updates in regards to this humongous crater that was discovered in Greenland back in 2018 that actually created quite a lot of buzz in the scientific community. And this new discovery, this new paper, or actually two different studies, seem to have finally identified the exact age of this crater, potentially helping us resolve one of the oldest mysteries in regards to the climate on the planet, or actually this very specific event that happened a few million years ago that the scientists currently do not understand at all. So let's discuss this in a little bit more detail, but I guess let's start with the crater itself and what the scientists were able to find. First of all, let's take a look at where all of this is located, just to actually help you understand why it took so long for the scientists to find this. This is part of a relatively large glacier, known as Hiawatha Glacier that you see right here, and the crater itself is sort of, well, it's really everywhere here. As a matter of fact, it's sort of visible in the image if you were to trace the outskirts of the crater by using the ice. But in this case, it was discovered completely by accident during one of the routine scans by NASA airplanes. And the discovery here was really big. Mostly, of course, because of the size of the crater. It's over 30 kilometers across. And the original discovery here suggested that this crater might have actually not been even that old. Some of the original assumptions even suggested that it could have been produced approximately 12 to 13,000 years ago, at least at the earliest. It could also be a few million years old, and so here the scientists didn't really know where to start counting. But if this crater was 12 to 13,000 years, this could also provide evidence to one of the more unknown phenomena known as the Younger Dryas period. The period where there was a sudden change in climate on the planet that lasted for a few hundred years. And several scientists in the past have suggested that it might have actually been due to some kind of an impact, with this idea referred to as the Younger Dryas impact hypothesis. But this is not a widely accepted hypothesis, and there is quite a lot of disagreement about some of the studies that try to prove this. Regardless, this was still an interesting discovery. Interestingly enough, a few months later, NASA has identified a second crater not so far away from the first one. In this case, it was slightly smaller and also potentially happened a few million years prior to the first crater, but it was still an interesting discovery and definitely showed us that we know so little about Greenland, and it does have quite a lot of secrets still hiding from us underneath all of this ice. But it was really this Hiawatha Glacier crater, or I guess Hiawatha crater, that's always been the most interesting to various scientists. And it was always about determining the exact age when this occurred. So first of all, when it comes to the size, 30 kilometers, that's one of the biggest craters on the planet. And it would have been formed by an asteroid approximately 1.5 kilometers across. Smaller than the one that killed the dinosaurs, but big enough to cause a major shift on the planet with potentially catastrophic effects affecting the entire planet afterwards. This impact would have been so powerful that it would most likely vaporize approximately 20 cubic kilometers of rock. And if there was ice in the area, it would have melted most of the ice, introducing huge amounts of water in the process. But although the initial assumption here was that the asteroid might have crashed into the already formed ice sheet, a lot of the evidence initially was very circumstantial. For example, a lot of this was based on the scans from the airplane, the radar scanning, with the important geological evidence obviously being hidden beneath 1 kilometer of ice, so obviously somewhat inaccessible to scientists trying to study the rocks. But inaccessible doesn't mean impossible, and so some of the recent studies from two different universities were able to collect enough data and enough rocks by using various riverbanks that carry meltwater from inside the crater and deliver all of the needed rocks that could then be studied. And so two separate teams, one from Denmark and one from Sweden, were able to independently collect just enough of these melt rock samples from several sampling sites located not so far from the impact structure itself. And on top of this, they actually used two separate methods to date the rocks, which represents two completely independent studies that seem to come to a relatively similar conclusion, which is extremely difficult to argue with. For example, one of the studies focused on the mineral zircon, and during a typical impact event, it will usually form new crystals which can incorporate various radioactive elements. And by finding the ratio of uranium to lead inside these crystals, it becomes possible to date the rocks determining their age. But the other study focused on a different technique using argon-argon dating. And instead of using rocks, they used sand collected from the river downstream. And by using argon, they determined that the sand in this case was most likely changed approximately 56 to 66 million years ago. And remember, the asteroid that killed the dinosaurs happened around 66 million years ago as well. But the study that used the rocks and uranium-lead dating determined the age to be closer to about 58 million years ago. In other words, the actual studies sort of coincided at that one date, maybe around 58 million years ago, plus minus a few million years. Which suggests several things. First of all, definitely not related to the younger, driest impact hypothesis. Second of all, the impact very likely happened when there was no ice in this region. The entire Greenland back then was probably a lot more warmer, it probably possessed a lot more trees, and might have actually been even tropical. But more importantly, this date, this impact, corresponds to another really unusual mystery that we've had trouble answering for a very long time. Let me show you this graph that I've showed you in some of the previous videos. This is a graph that sort of shows us the average temperature on the planet in the last 65 million years, essentially since the extinction of the dinosaurs, most dinosaurs, with the present day being somewhere right here. Now look around the graph and see if you see anything unusual. Okay, let me zoom in. There's a very unusual spike in temperature that we still cannot explain that happened approximately 55.5 million years ago. It's usually referred to as PETM or Paleocene-Eocene Thermal Maximum. Basically when the planet suddenly became extremely hot, something that probably lasted for at least 20,000 years. And even today there was no exact explanation for what might have happened here. Until, I guess, now. There is currently an extremely high chance that somehow this might be actually related. This relatively large crater that's only about 5 to 6 times smaller than the crater that killed the dinosaurs might have produced just enough destruction and released just enough gases into the atmosphere that it could have been responsible for this unusual event that currently does not really have a very good explanation otherwise. Now it's still not exact in terms of dates, 58 million versus 55.5 million, but further studies and further investigations of the crater might determine this with a little bit more accuracy. Once again, still a huge hypothesis and basically just a huge speculation on my part, but definitely something worth investigating and worth exploring a little bit more. And because this is such an exciting crater that was discovered only a few years ago, and probably the most exciting crater discovered in the last few decades, trying to figure out exactly what effects this had on the planet and how it might have affected evolution on the planet is of course something the scientists would love to find out more about. Naturally, a rock that's about 1.5 kilometers in size that produced a crater that's about 31 kilometers in size is not something that we can sort of ignore. It definitely had some kind of a major impact on the planet. But I guess until future studies, we're not going to know more. Although I guess we've been getting really good at finding these new craters, and I'm sure we'll discover a lot more, possibly even in the regions we've never looked at. For example, not so long ago, actually just a few days ago from when I'm making this video, completely by accident, the scientists looking at northeast China discovered what they refer to as Yilan crater, a crater that's about 1.8 kilometers across and is now officially the largest crater created on the planet in the last 50,000 years or so. The previous record holder was the famous meteor crater located in Arizona. And this crater is believed to have been created anywhere from 46 to 53,000 years ago by a rock that was probably around 50 to 70 meters across. It wasn't really that large, but it was large enough to produce this relatively large formation. Something that we do believe happens on the planet at least every few thousand years or so. When it comes to dramatic climatic changes on our planet, volcanoes have always been the biggest contributors, often changing the aerosol concentration in the atmosphere, which would then reduce the temperature on the planet by at least half a degree for several years. But when it comes to powerful volcanic eruptions, we don't really know much about them in terms of historical events. Mostly because trying to understand how many times the climate on the planet was changed because of the volcanoes or because of something else has always been somewhat difficult and has always presented quite a lot of problems. But that's, I guess, until now. Hello wonderful person, this is Anton, and today we're going to be discussing this new paper that was able to discover quite a lot of extremely powerful volcanoes that happened in the last 60,000 years on planet Earth, many of which have never been seen before and many of which most likely changed the climate of the planet to some extent. And so let's discuss this discovery in a little bit more detail, but I guess let's start with some of the most recent detections of volcanic eruptions that we know influenced the planet. As a matter of fact, this year, 2022, started with one. The eruption of the volcano in Tonga. The eruption that was so powerful that it sent different shockwaves across the planet that traveled the planet several times. And the eruption that we discussed in one of the previous videos and that we think is going to influence the temperature on the planet at least to some extent. But we'll talk more about this eruption in one of the future videos. This was not even that powerful compared to something else. Compared to the eruption of Krakatoa in 1883 that became one of the most catastrophic eruptions of recent times, resulting in nearly 37,000 people dead and huge tsunami waves that traveled across the entire planet. And just like the eruption in Tonga, this wasn't a single event. This was actually several different explosions, with the third explosion being the loudest sound produced in recent times. According to some of the recent discoveries, at a distance of about 60 kilometers away from the volcano, the volume here was about 180 decibel, which was loud enough to be heard several thousand kilometers away and loud enough to not just rupture the ears of anyone within a few kilometers away from the eruption, but to even produce a pressure wave that would blow out the alveoli in a typical lung. So by being within about 10 kilometers away from the eruption, everyone who lived on the nearby island unfortunately perished, with some of the sailors on a ship 60 kilometers away from there also experiencing ruptured ears. And following the eruption, for roughly around 5 years, the overall temperature on the planet decreased by around 1.2 degrees, mostly due to the large amounts of sulfur dioxide released as a gas into the stratosphere, with sulfuric acid also being responsible for some of the lowering of the temperature. And all of these aerosols also affected the clouds, increasing the reflectivity of the clouds in the upper atmosphere, which then causes the global temperature to decrease for at least a few years. And so at least a few really powerful blizzards were reported in the years after the eruption, although none of them were dramatic enough to affect the harvest. Something else happened earlier in that century that did actually produce a much more powerful eruption. In 1815, a little bit to the east, there was another much more powerful eruption known as Tambora, the eruption that produced the caldera that you see right here. And this particular eruption was dramatically more powerful, resulting in at least twice as many casualties and reducing the temperatures around the planet even more. As a matter of fact, the eruption of 1815 resulted in what's known as the Year Without Summer, the strange year that resulted in a lot of famine around the planet, resulting in some of the strangest weather on the planet. And today this particular eruption is considered to be the largest one in the recorded human history, at least in the last few thousand years, scoring the impressive 7 on the so-called volcanic explosivity index, which usually determines how powerful and how influential a volcanic eruption would be, with Krakatoa scoring a 6, and the most recent eruption of the Mount Pinatubo in the Philippines also scoring a 6 as well, with several other volcanoes scoring a 7 happening hundreds and hundreds of years ago. There was a mysterious volcanic eruption in 1400s in Vanuatu, another eruption in Indonesia in 1200s, a Korean eruption in the 10th century, and an eruption in New Zealand in the year 181. And generally it's believed that these eruptions happen at least once per 100 or 200 years. But that's the so-called 7s. What about 8s? Well, when it comes to the most powerful eruptions, the 8s, up until a few months ago, there was really only one known, the so-called Toba eruption, with this beautiful Lake Toba that you see right here forming the caldera. And once again, this happened in Sumatra, Indonesia. And it happened approximately 74,000 years ago. And this is of course the time when the ancient humans already existed and already were slowly propagating across the planet, including the regions in Indonesia. But interestingly enough, when some of the scientists studied some of the genes of modern humans, they discovered that around the same time, there was an unusual and sudden decrease of total number of humans on the planet. At some point, there were only about 20,000 people left. And today this is known as the bottleneck theory, with the most common explanation being the Toba catastrophe. Here the idea is really simple. This tremendously powerful volcanic eruption caused so much destruction on the planet that it almost entirely caused our species to go extinct. But the thing is, some of the recent studies, such as the one that you can find in the description below, argue against this because they've also discovered that in certain regions of India, nothing seemed to have changed for some of the humans living in those areas. Their numbers did not increase by much, and their actual lifestyle did not change either. And in this case, they took a look at quite a lot of different locations on the planet, discovering that for the most part humans were doing okay. So the numbers could have actually decreased for some other reason as well. Nevertheless, such a powerful eruption would very likely cause a volcanic winter lasting 6 to 10 years, and would also lower the average temperature on the planet for at least a 1,000-year period afterwards. But because back then humans were hunter-gatherers, it might have actually not affected them as much. Although the actual details of the effects and what exactly happened to early humans is not something we can answer right now. But there is one thing we can answer. We can actually find more of these eruptions using some of the modern techniques. And that's precisely what the scientists behind the recent paper decided to do. They decided to study some of the ice cores, discovering signs of thousands of different volcanoes that happened in that period. In this case, using the cores from Antarctica and Greenland that contain some of the ancient signs of sulfuric acid, the signs of which usually represent an extremely powerful and very impactful volcano, much more powerful than anything we've seen in the last few hundreds of years. And according to the scientists, at least 85 volcanic eruptions in the last 60,000 years left visible signs of their impact, with 69 volcanic eruptions very likely being more powerful than Tambora eruption of 1815. With the most powerful eruptions visible in this image right here. The bigger the circle, the more powerful the eruption. Tambora in this case, which was the most powerful recent eruption, represents a relatively small circle. Yet the eruption of Lake Taupo in New Zealand, the eruption that happened many times before, was one of the most powerful in the last 30,000 years, very likely being very similar to the eruption of Toba 74,000 years ago. And every eruption they discovered in those ice cores is definitely much bigger and much more powerful than anything we have record of. Hundreds or even thousands of times more powerful than the eruption of Tambora in 1815. With their data also showing us that something extremely powerful happened 55,000 years ago as well. And also showing us that pretty much most of these very powerful volcanoes dramatically affected the planet for at least 5 to 10 years in terms of the actual climate. And the top 25 eruptions on this list are bigger than anything that happened in the last 2,500 years. And all this of course means one thing. Powerful volcanic eruptions are a lot more frequent than we originally thought. And they also influence the climate on our planet quite dramatically as well. And because there hasn't really been a very powerful eruption in the modern times, it's kind of difficult for us to predict or to try to understand what would happen to our civilization if such an eruption were to occur. On January 15th of 2022, planet Earth gave us a bit of a surprise, one of the largest eruptions we've ever seen. The eruption of Tonga volcano that destroyed 90% of the entire island where it was located, creating an enormous plume cloud that was several thousand kilometers across, while also generating a very powerful sound wave that traveled across the planet several times. As a matter of fact, this was one of the loudest sounds ever produced, at least in modern history, even being detected by various seismological stations around the world and GPS satellites that detected slight disturbances in their data. But in the last few months there have been some updates and some really interesting discoveries about this eruption, and we're going to be discussing them today, starting with this recent study that as always you can find in the description below, where the scientists were able to design an algorithm that used these seismic detections from the volcano to estimate the amount of volume ejected by the volcanic eruption, in the process discovering that this was the largest explosive eruption of the 21st century, equivalent in power to the 1991 Pinatubo eruption in the Philippines. And so by using a similar algorithm, the scientists believe they can now actually calculate the eruption power of very remote volcanoes and thus study volcanism without really being on site, while at the same time being able to predict how much volcanic ash is going to be released by a certain volcano, and thus predict if the volcano is going to be very disruptive or potentially very damaging to people nearby. You can learn more about the research in the paper in the description below. Then, by using data from a lot of different GPS satellites, some of the scientists were quite surprised to find out the extent of the effects of the volcanic eruption and the length of these effects as well. First of all, it became apparent that a lot of the atmospheric waves created by the explosion were actually active for at least 4 days after the eruption, and also ended up going around the planet at least 3 separate times. For example, here is the altimeter data collected by these GPS satellites approximately a couple of days after the eruption. You can see the waves moving back and forth. While at the same time, all of this caused a lot of the disturbance in the upper atmosphere, including what's known as ionosphere that we're going to discuss in a few minutes. And so the shockwave that you see propagating right there was actually traveling around the planet several times. In this case, this is a shockwave that was detected by measuring the water vapor levels using a satellite known as GOAS-17. But it's really the effects on the ionosphere that were most surprising and to some extent most unusual. So first of all, one of the teams using the pictures from satellites was able to estimate that the volcanic ash rise to the altitude of about 58 kilometers or 36 miles, with some of the other stuff like gas, steam and ash even reaching mesosphere. And that's actually believed to be double the altitude of the Philippines volcano in 91, the Mount Pinatubo. And following this, it took approximately 13 hours for all of this plume to disperse. But ultimately, some parts of the plume were able to almost reach space. As you can see, it was actually at an altitude of about 85 kilometers. This was surprisingly calculated by looking at various shadows formed by the plume itself. Now normally, in order to calculate an altitude of a cloud, the scientists will use the measurements from infrared instruments and some of the models that compare simulations with temperature and altitude. But in this case, the method relies on the idea that the temperature will decrease at higher altitudes. Yet we know that once you go high enough in the atmosphere, something different happens. The temperature can actually start going up. And that's sort of what started happening with the volcanic ash, which made it almost impossible to calculate the maximum altitude. And so some of the scientists from one of the papers below managed to find a different solution. They used a stereoscopic observation using 2 different satellites to create a 3-dimensional picture, and then use some of the shadows to calculate the maximum altitude that way. In the process, obviously discovering that a lot of the stuff stayed in the upper atmosphere for a very long time. A lot of the volcanic ash, including things like sulfur dioxide, carbon dioxide, water vapor and so on, eventually get distributed across the entire planet, with aerosols persisting in the stratosphere for at least a month. Although in this case we believe it might even stay there for at least a year. But at the moment, the calculations suggest that it's probably not going to influence the climate of the planet for the next year or so, or even change the average temperatures on the planet by more than half a degree. Nevertheless, because a lot of the material in this case reached the upper atmosphere, including of course the pressure wave, all of this ended up even influencing ionosphere and reaching outer space. In this case, 2 satellites measuring ionosphere, such as NASA's ICON, also known as Ionospheric Connection Explorer, and ESA's SWARM satellites, discovered that a few hours after the eruption, there were quite a lot of extremely fast winds and very powerful electrical currents formed in the ionosphere. That's of course the region on our planet where we usually detect things like Aurora or a lot of other electrical activity. And so this eruption ended up electrifying some of the upper layers of the ionosphere, creating one of the biggest disturbances in outer space we've ever seen. And so in this case, it's believed that as the volcano erupted and pushed this huge amount of gas, water vapor and dust into the outer atmosphere, it ended up creating extreme winds that expanded into the upper atmospheric layers, with certain winds moving at speeds of over 200 meters per second, a little bit slower than a typical jet airplane. And this is also the fastest winds ever measured by these missions. And as the winds propagated in the upper atmosphere, they started to influence some of the particles in the ionosphere as well. For example, there is an electric current phenomenon in our atmosphere known as the equatorial electrojet, EEG for short. And it turns out after the eruption, this particular jet increased in power by approximately 5 times. And also ended up flipping its direction as well. Instead of going eastwards like usual, It even started flowing west for a short period of time. And this is something that's only been seen before during extremely powerful geomagnetic storms coming from our sun. And since these electrojets are usually associated with the movement of material in the ionosphere, and can even disrupt satellite communication or radio signals, it sort of suggests that powerful volcanic eruptions do have a very similar effect to a geomagnetic storm. Something that nobody has ever thought of before. Although it's still not entirely clear how all of this works and why this effect even occurred. Some of the explanations suggested that it's something to do with the phenomenon known as the Lamb waves, the waves that are generally able to travel around the planet without reduction in amplitude, but that's just a preliminary explanation, and at the moment it's still unclear how this particular eruption affected so many parts of the atmosphere and ionosphere. Although it's pretty clear now that a typical volcanic eruption does have a lot more influence than we originally anticipated. But I guess one of the bigger questions that currently we can't really answer is why exactly was this volcanic eruption so extremely powerful? What exactly happened here to cause such a huge explosion? Well, one of the explanations suggests that there was a smaller eruption very likely a day before. And because of this first eruption, a bigger part of the volcano ended up sinking underneath the surface of the ocean. And then, as all of the molten rock during the second eruption started to come out and interact with seawater, it vaporized and ended up intensifying the eruption that would be slightly less powerful otherwise. As a matter of fact, the vaporized seawater very likely caused a lot of the lava to turn into tiny pieces of ash. And when all of this combined with ice crystals in the upper atmosphere, this also ended up creating a huge amount of static charge, creating something like 10,000 lightning strikes per hour, and representing roughly around 80% of all lightning strikes on planet Earth during that particular day. With the research in this case suggesting that the violence of this volcano was really due to the fact that it was an underwater, a submarine volcano. The combination of energy from the eruption, along with the mixture from water and atmosphere, ended up releasing way more energy than was possible otherwise. And because we know that this volcano erupted previously, for example here's a picture from 2015, with the eruption being just a little bit less powerful but obviously not creating the same effects, this particular suggestion does make a lot of sense. So mixing water, volcano and certain atmospheric conditions does produce way more energy and creates dramatic effects that would be impossible otherwise. When it comes to freak weather events, 2022 so far has been pretty bad. We've had anything from extreme heat waves, to extreme rainstorms, and to now, drought that seems to affect a lot of areas on the planet. And just a few days ago, this picture surfaced on the web. These are 117 million-year-old dinosaur tracks that were accidentally discovered in one of the rivers in Texas that has now dried out. The tracks were always there, but so was the river. And because of the drought, this sort of became visible. You might have heard similar stories from the last few weeks about various Second World War ships discovered in rivers in Europe, the ships that were missing up until now, and even the discovery of so-called hunger stones discovered in various locations in Europe, which are essentially stones with some kind of a message written on them, kind of indicating that there could be a famine coming because of the drought that seems to be happening. But today, as you can probably tell from the title of this video, we're going to be talking about something slightly different. We're not actually going to be discussing the results of the drought. We're going to be talking about some of these scientific advances when it comes to weather control, or essentially preventing various droughts, or trying to control weather in some other way in order to create sustainable conditions. And the reason I wanted to make this video is because of this article in BBC that was recently published, that essentially once again talks about China, and in this case, it talks about how Chinese authorities are trying to induce rainfall by using a technique known as cloud seeding, something that China has actually become extremely good at. And so today we're going to talk a little bit more about these techniques, the history of these techniques, and more importantly, if they actually work. And by the way, this article is in the description below. And naturally, we can't really talk about weather control without mentioning some of the more ancient history. And here we're talking about various rituals or various unusual things that people used to do in order to, I guess, induce rain or stop rain from happening. For example, many different rituals were practiced in ancient Greece, with many of them specifically for weather control. And many involved either some kind of a sacrifice or some kind of a relatively large fire that would be used to burn something. In slightly more recent times, during the Viking Age, the Vikings strongly believed that the Finnish people were actually really good at controlling weather through various rituals. And for this reason, they always refused to take Finns on their ocean-going raids, truly believing that the Finns might actually change the weather and thus sink the ships. And even more recently, in the late 1500s, we had the North Berwick witch trials, where several women were trialed for an attempted murder of King James VI by essentially changing the weather when he was on a ship and causing the ship to sink. So in other words, this idea of weather control and specifically rituals that were used to control weather have always been part of human legends and various stories from various regions. And although the weather control in this case was really more anecdotal and very likely not real, a lot of rituals from various cultures, as I mentioned before, would often use fire. And there's actually something really interesting that was discovered approximately 200 to 300 years ago. During various Napoleonic wars or during the American Civil War, soldiers reported that every major battle that involved a lot of gunpowder would always be followed by a lot of rain. Something that the United States government even tried to test back in the late 19th century by firing a lot of gunpowder somewhere in Texas, although those initial results were somewhat inconclusive. But this was the birth of that idea that you can technically provoke rain or that you can use certain chemical reactions to try to control the weather. But it wasn't until the World War II, and specifically right after the World War II, that the actual scientists started to try to test this in order to maybe control the weather. And the first such person to ever do this was the American Vincent Schaeffer, who was actually a researcher for General Electric and was able to conduct the first seeding experiments back in the 1940s. But as things usually are in science, all of his discoveries were completely accidental. He was actually trying to study the icing effects on various high-flying aircraft, but completely by accident was able to create quite a lot of condensation in his homemade freezer that led him to understand that it's actually possible to form condensation and rain and snow through various chemical reactions. And so in 1946 he conducted the first ever cloud seeding experiment using aircraft, where approximately 3 kilograms of crushed dry ice was dumped from the airplane into the Adirondack Mountains in New York, which, to his surprise, almost instantly resulted in snowfall. And that's how he shifted his research, with a lot of further research then establishing that there are certain chemicals or certain particles that do this much more effectively, with silver iodide eventually being discovered to be the best. Here's actually just one of many pictures of these so-called cloud seeders, in this case on a small Cessna airplane, that are used for a lot of different types of cloud seeding. And naturally, all of these early experiments very quickly captured the attention of the US government, and specifically for two main reasons. One being military use, but two being a way to control potentially dangerous hurricanes. And so in the early 60s, the US government conducted what's known as the Project Storm Fury, with the idea being relatively simple. By seeding a lot of silver iodide somewhere around a major storm, it might become possible to create another eye of the storm nearby, thus reducing the overall pressure, and more importantly, reducing the wind speed overall. With this cloud that you see right here being a result of this dispersion in the tropical storm Dorothy. With this picture right here showing some of the first pilots that were conducting these flights. But eventually by 1971, it was determined that most hurricanes just don't have enough supercooled water for the cloud seeding to become effective. And so the entire experiment was eventually scrapped. And I guess more intriguingly, certain events, such as the 1947 Project Cirrus, even led to several litigations and lawsuits because one of the hurricanes during that time changed directions hitting another state. And though initially this particular change in direction was blamed on the seeding, eventually the scientists realized that the seeding itself did not really affect hurricanes almost at all. Although this did not stop other scientists from trying other things. For example, some scientists proposed that by using various very powerful jet engines that are pointed upwards, it might be actually possible to disrupt the progress of the incoming hurricane, although this has not been tested just yet. It's also been proposed that by dumping large amounts of environmentally friendly oil on the surface of the sea, it might be possible to prevent the formation of droplets and thus reduce the strength of the hurricane. But because this could potentially lead to a major disaster involving the oil, this has not been tested either. Some scientists suggested using lasers to try to create lightning inside the storm, once again in order to reduce some of the strength. Or cooling down the oceans around a hurricane by pouring large amounts of liquid nitrogen in order to reduce the total heat energy. Both ideas a little bit too expensive and a little bit too extreme to be tested, so nobody ever has. But one idea was tested, using a patented product known as Dinogel. The gel that's supposed to be able to absorb approximately 1500 times its own weight in water. And the idea here was really simple. By dumping this polymer into the clouds, it would then absorb a lot of the moisture from the clouds, which would then result in the storm reducing its total energy because there's now much heavier droplets on the inside, which would eventually dissipate the storm. And this particular idea was tested in 2003 in Florida, with this article that you can find in the description describing what happened. But in a nutshell, there might have been some effects and the storm might have weakened and even disappeared from the radar, but the thing is, the scientists determined that you would require huge amounts of this material, and we're talking about like tons and tons of this material, to be dispersed into the clouds in order to become effective. And because this would have to be done quite regularly, this would result in tons of new pollutants. And so stopping hurricanes is still not something we can actually do. But these early experiments definitively established that it is possible to induce rain and induce snow, with many countries like Thailand and China, of course, kind of picking up the idea and starting their own experiments as well. As a matter of fact, one of the first projects in the world involving some kind of a government trying to create rain was in Thailand. It was the Royal Rainmaking Project. US naturally had their own program as well, but back then, US focused their efforts on something a little bit more, I guess, evil. And here it's the previously secret project known as Operation Popeye, an attempt to use cloud seeding to increase the strength and the length of various monsoons in Vietnam during the war in Vietnam in the 60s and in the 70s, with the main purpose being the destruction of logistics and specifically disruption of military supplies by prolonging various monsoons and increasing the chance for landslides. And though initially this was a secret program, when the program became declassified, almost right away this idea sort of became banned. And quite a lot of countries eventually signed the agreement to never use weather control against any other state, making the idea of weather manipulation for either military or political reasons illegal according to international law. But inducing rain in your own country is still legal and has actually been pursued by various countries on the planet. Most of these countries do need this rain to survive. For example, the Arab Emirates have been doing so successfully every single year since the early 2000s, with the main aim being the increase in rainfall by at least 30% per year, with various chemicals used for this purpose, but silver iodide still being one of the best. Although here it's important to understand that you still need to have some kind of a water vapor in the air in order for the cloud seeding to work. And in this case, the crystals of silver iodide then kind of function similar to ice particles, because they actually end up attracting more water droplets, which form larger and larger drops as a result. And though normally it produces snow, depending on the temperature, it will also produce rain. Or at least that's the main theory. The actual way it works, it's still not entirely clear. As a matter of fact, even today the scientists are not certain how well this technique works, or if it works in all climates. And actually one of the most rigorous projects that try to study the effects of seeding on the production of snow was only conducted in 2017. It was the project known as SNOWY, Seeded and Natural Orographic Wintertime Clouds. This project was conducted specifically in an area that was not expecting any snow or precipitation, and by conducting several flights and using silver iodide particles spread across this area, the scientists were definitively able to produce snow and thus show that it seems to work. But when it comes to taking these ideas to the next level, it's really China that seems to be doing the most. As a matter of fact, in 2020, they've officially announced that by 2025, they plan to expand the rainmaking capability to be able to cover roughly 60% of the entire country. Or in other words, they want to be able to create rain in most of the regions here. But are they going to be able to do it? Well, here's what we know so far. First of all, in 2005, China officially signed a treaty promising not to use this technology for any political or military reasons. And in 2008, during the Beijing Olympics, allegedly they used over 1,000 different rain-suppressing rockets to make sure that the Olympics were dry, that there would be no rain anywhere. Now it's not clear exactly what they used in those rockets and if it was successful because they did so or because it was just an accident, but that's the fact. They definitely tried to suppress the rain. Then within 7 years, by 2015, they actually had these hail suppression programs and rain-making programs in 30 different provinces, with the total number of employees being over 30,000. In other words, they had the world's biggest weather-making program, employing actual government workers. Several neighboring countries have already expressed concern about this, because by basically having more rain in China or less rain in China, all of this precipitation can then be taken away from other countries or potentially cause other countries to have more rain. As a matter of fact, South Korea, that has recently experienced absolutely insane rains that have never been seen before, might have been one of the first victims. At the moment, this is just rumors and gossip, but it's been suggested that it's actually because of these weather modification programs in China that suddenly both Korea and Japan experienced some of the highest rainfall ever. China has also used the rain-making program around highly polluted areas in order to try to use the rain to basically wash away the pollution from the air. And it's even been suggested that China has been doing this pretty much every year now in order to maintain low levels of pollution in cities like Beijing and Shanghai. As a matter of fact, not so long ago, China reported launching 16 rockets around Beijing, and the rain followed pretty much right after. And though at the moment they're using this as a success story, in reality we have no idea what long-term effects this is going to have. Or more importantly, what effect this is going to have on all of their neighbors as well. But I think we're going to find out soon enough. Hello wonderful person, this is Anton, and today we're going to be discussing this somewhat interesting proposition, although somewhat controversial proposition, in regards to how plate tectonics work on planet Earth. Or to be more exact, what's actually causing the motion of plate tectonics themselves. And this particular proposition is quite intriguing because, well, it sort of makes some sense. With the main idea here suggesting that the plate tectonics on our planet are not just caused by the internal motion, not just caused by the convection inside the mantle, but instead the majority of the plate tectonic motion might actually be caused by the gravitational forces from the moon and from the sun, with the main premise being the idea behind barycenter formed by the moon and planet Earth, and the actual motion of the barycenter inside our planet. So I wanted to explain a little bit more about this proposition, why it kind of makes sense, and also briefly discuss how some of the future studies might be able to prove or disprove this as well using some of the other objects in the solar system. But I guess let's start with the basics. Plate tectonics. The concept that possibly is one of the main reasons our planet is able to sustain permanent conditions on the surface, and to some extent why our planet has life and had life for such a long time. As a matter of fact, the vast majority of scientists and studies published in the last few decades pretty much unanimously agree that plate tectonics is one of the main reasons for not just the existence of complex life on the planet, but also for our existence, the existence of very complex intelligent life. And the main reason behind this is because plate tectonics allows the planet to recirculate all sorts of different materials through various processes involving volcanism, with nearly 500,000 volcanic eruptions visible right here, and various weathering processes which usually trap all sorts of compounds inside rock, and which then is recirculated back into the atmosphere a few 100,000,000 years later. While on the other hand, the absence of plate tectonics on, for example, the sister planet Venus has always been suggested to be the reason for why Venus is such an extreme planet, with extremely high pressures, temperatures, and just everything being over the board. And although in some of the previous videos that you can find somewhere right here, or possibly in the description below, we have discussed the possibility of Venus potentially having plate tectonics, today it's believed that Venus for the most part does not have any motion on the surface, and because of this nothing can be recirculated anymore. But even though this process is clearly very important, today it's still not entirely clear on what exactly drives the process of plate tectonics, and why of all planets we know so far, only Earth seems to have it. For example, when it comes to explaining why Venus doesn't seem to have any plate tectonics, some of the previous explanations suggested that due to the lack of water, which plays an important role in the development of what's known as the shear zones, the Venusian crust might have never become weakened enough, because that's essentially what water in the crust would do to it, to break it into different pieces. And so despite the fact that Venus might contain other necessary conditions for plate tectonics to exist, the lack of water might explain why there's nothing here. But that's a very preliminary explanation, and it seems that it doesn't explain everything. And when it comes to our own planet, it's not even entirely clear when plate tectonics started here. some studies suggested approximately 3 billion years ago, some studies suggested 3.5 billion years ago. Either way though, it looks like it took approximately a billion years after the formation of the planet for all of this to start. And interestingly, after the formation of plate tectonics, that's when a lot of scientists believe many materials from within the planet, such as for example phosphorus, which is absolutely essential for life, might have been brought to the surface, allowing for life to evolve. So basically this could have kickstarted the life on the planet as well. But what exactly caused the plate tectonics to start? Well, a lot of modern theories essentially suggest that the convection cells present inside the mantle of our planet, as they sort of circulate around, first of all end up producing all sorts of motion inside the mantle of the planet, mostly due to the temperature difference and a lot of heat exchange, which then ends up disrupting the crust on top and moving the continents as a result. With this beautiful simulation you see right here, showing us both the surface of the planet and the structure of the mantle underneath. And that's of course the explanation we've had for a few decades now, sort of helping us understand how plate tectonics might work and what's causing the continents on our planet to move around and to interact. But there's always been a few unanswered questions. For example, some types of plate tectonics or continental motion is very difficult to explain. On the other hand, certain simulations conducted by scientists do not match the actual observations from planet Earth. And even though we know for a fact that the convection inside the planet definitely happens, and the heat generated through the internal radioactivity definitely causes some of these observed effects, it's possible that not everything is caused by the heat from the planet. Something else could be going on inside our planet or even outside our planet to create the effects we're observing on the surface. As a matter of fact, several studies have already established that it doesn't seem like there is enough heat generated from within the planet to actually drive such a massive activity on the surface and to create the effects we're observing from all of the plates moving at all times. You can actually find some of the values calculated from all of this activity in the paper in the description. And if the heat from within the planet is not enough to drive plate tectonics, what else could be causing these effects? Well, one of the main ideas in the paper is actually pretty simple to understand. It sort of explains that plate tectonics do not really depend on the heat as much as they depend on some sort of a lateral or sideways force that's causing the actual continents to move around and to interact. Or more simply, the heat in this case is not as efficient at moving things as the force itself. But where exactly would this force come from? Well, the obvious explanation here would be the effects from the moon and possibly the effects from the sun. And one of the better ways for me to explain this to you is to actually use Universe Sandbox to create a simulation involving the Earth, the moon, and of course our own sun located somewhere right there. So we obviously know that as the moon orbits around Earth, it creates a lot of tides and a lot of other effects. But the sun also has a bit of a pull on our planet, and as a result they do generate all sorts of tidal activity. But because our moon is considered to be quite large and quite massive for a typical satellite, as the two objects orbit around one another, they create what's known as a barycenter. In essence, it sort of looks like this. It's this tiny point or tiny cross you see right there, around which the Earth and the moon create tiny orbits. And if the planet is much larger than the moon, the barycenter is almost completely invisible. Whereas if the objects are comparatively similar to one another, the barycenter becomes more apparent as well. This is an example of what Pluto-Charon system might look like. And by the way, here are the actual images of Pluto right there in the middle and its moon Charon orbiting around the barycenter. But the Earth-Moon system also has the Sun, and our Moon is also not in the same orbital plane as the Sun. And as a result, if we look at the barycenter that's located right there, because of the interactions with the Sun and also because of the misalignment with the Sun, the barycenter ends up sort of moving by roughly around 600 kilometers away from the center where it would be otherwise. And though the actual barycenter is located about 4600 kilometers away from the center of the planet, with this figure showing us that it's somewhere right here, because of the interaction with the Sun, it does move and shift quite a lot by approximately 600 kilometers, going between about 4000 and 5000 kilometers away from the center, but more or less still being inside the central mantle. And at the same time, it also is always going around the planet and is always sort of following along with the moon. So basically, even though the planet, as you can see, spins really fast, the barycenter is always aligned with the location where the moon is facing. In other words, it sort of follows the moon, as you can see right here. And as a result, this creates quite an enormous gravitational stress inside our planet. And because of the constant changes in depth, it also creates a lot of different imbalance and a lot of internal stress, which then very likely reflects on the surface of the planet. And although generally the highly pressurized and very hot interior of our planet can easily withstand this stress, when it comes to the more brittle and cold surface of the planet, it's a different story. It very likely starts fracturing as a result, which is also reinforced by the centrifugal forces due to the spin of the planet. So as you probably know, right at the equator our planet is actually slightly bulged out. And all of this stress then reflects on the crust, with crust breaking and creating continents which then move around. And so the paper here suggests that it's actually the stress coming from the moon, from the sun, and from the spin of the planet that seems to actually create most of the plate tectonic motion. And specifically, it's the somewhat unpredictable motion of the barycenter that wobbles all across the mantle, constantly changing the forces and constantly causing different stress on different parts of the planet. And although obviously the internal heat still plays some role in this, for the most part the paper here suggests that these particular effects are somewhat minimal in comparison. Although you do probably need both for the plate tectonics to work really well. If the planet cools down or if the moon moves far enough away from planet Earth, all of this could stop completely. Although the existence of a really large and really massive moon in this case plays the most important role. If it wasn't for the effects coming from the moon and from the gravitational interactions with the moon, none of this would probably be possible. But here we also have to remember that this is just a very preliminary proposition. As a matter of fact, it would take quite a lot to prove this. And in this case, the scientists do propose at least a couple of ways we could maybe prove this, by looking at other objects. For example, similar effects might be happening on Pluto because of its really large moon. And if we actually find some tectonic activity here, because Pluto is believed to be relatively cold on the inside, it would mean that the plate tectonics here are driven entirely by these gravitational forces and not by internal heat. And since in the past it was already discovered that the surface of Pluto seems to be really young, approximately 10 million years old, it sort of does imply that there is some kind of a very active geological activity on the surface, which also means that it's a planet, as I've described in one of the previous videos you can find right there or in the description below. Okay, so here's an interesting proposition. What if all of these mountains you're looking at right here were actually created because of the effects from the biosphere, from life? Or in other words, what if a lot of these really large mountains on our planet were actually sort of created with the participation of life itself? Now that's quite a proposition, but that's exactly what this new paper you can find in the description below proposes. And it sort of makes sense. Hello wonderful person, this is Anton, and today we're going to be talking about this somewhat interesting and possibly groundbreaking study that might help us understand how biosphere influences the geology of our planet, and might also help us understand how all of this would work on other planets as well. So let's discuss this in a little bit more detail, but let's actually start right here, on another planet that has geology we're quite familiar with, planet Mars. Now, interestingly, the geology of Mars is extremely different from what we have on our own planet. For example, you're not going to find a lot of stereotypical mountains. You're going to find things like this right here, this really huge valley you see known as Valles Marineris. And you're also going to find places like Olympus Mons, or the biggest volcano in the solar system, but none of them are anything similar to what we have on planet Earth, and were actually formed in entirely different ways. And the main reason behind this is because Mars doesn't have the same geological functions or the same geological activity as planet Earth. For example, it doesn't have what's known as plate tectonics, the phenomenon best described in this simulation here. So here, on Mars at least, the continents don't actually exist or don't flow around, don't interact, and don't create any formations that they do create here on planet Earth. Now, one of the best ways of trying to understand how all of this works is this relatively simple simulation, the link for which you can find in the description below, created by the wonderful people from University of Colorado. It actually helps you understand how continental crust works, how the composition and, for example, thickness changes the interaction of the crust with some of the other types of crust. But more importantly, it helps you understand how various plates interact, creating various formations. For example, if we have a very thick continental crust right here and somewhat thinner oceanic crust right here, and the two start to collide forming the convergent plate, at some point a lot of the deposits from the oceanic crust are going to start melting, evaporating, and eventually creating volcanoes on the surface of the continental crust. And those volcanoes are going to create mountains, with the best example being the iconic Mount Fuji in Japan. Then in some other cases, when two continental shelves start to smack into one another, so kind of like this, they'll end up squeezing each other so much that they'll end up producing even more mountain ranges, and actually some of the biggest mountain ranges on the planet. The best example of this is the Indian plate squeezing into the Eurasian plate and creating the iconic mountains in the Himalayas, including of course Everest. And so that's the geological basics of planet Earth. A lot of the mountains here are produced in one way or another through the interaction of various plates. And that's of course one of the reasons why we're not going to be finding a lot of similar mountains on other planets, and especially planets that don't have plate tectonics. But I guess the question is, what does life have anything to do with any of this? It's still a geologic process, and it's still something that any planet in theory can have, assuming that it has plate tectonics as well. Well, it turns out that quite a few papers in the last decade or so discovered that one of the main reasons Earth has so many different mountains and such large mountains is because of the existence of graphite that's present in a lot of different shelves, continental shelves, that interact with one another. And so the addition of graphite, or basically carbon, into the rock inside different tectonic plates made the rock on the inside a lot more brittle and a lot more likely to stack, to go under one another, and created the necessary conditions for the plates to do this. But this new study took it a few steps further. They've established a somewhat difficult to ignore correlation between the existence of ancient life and the formation of various mountains on the planet, specifically identifying a tremendously large formation of mountains around the same time as one of the biggest explosions of life on the planet, during the so-called GOE, Great Oxygenation Event, implying of course that without this ancient life, a lot of mountains on planet Earth might have not even existed at all. And to be more specific, in this study they focused on 20 different mountain ranges around the planet, including of course some of the mountains in the Rockies, some of the mountains in South America, the Himalayas, and a lot of other famous mountain formations with specific age of their formation identified in the paper as well. As you see from this image, for example, a lot of these mountain ranges mostly formed between about 2.3 and 1.7 billion years ago, with this graph clearly showing that there was a very large and pronounced period of mountain formation right here about 2 billion years ago, then another one about 1 billion years ago, and then another one about 500 million years ago. In other words, even though you expect mountains to be more or less be created kind of equally across the time scale, in reality a lot of the mountain ranges on the planet were created in bursts and usually around the same time period, which by itself is already a bit of a mystery. And so the scientists in the study sort of made an assumption. There might have been a source of all of this burst of formation, and also at the same time possibly connecting all of this to the presence of graphite that's responsible for making mountains easier to produce. And specifically here, the link is between the ancient life and the high amount of carbon being buried in the sediment. All of these tiny ancient organisms that were present all over the oceans approximately 2.5 billion years ago, especially the organisms that became extremely successful during the Great Oxygenation Event, as they essentially sank to the bottom of the oceans, got integrated as carbon into a lot of this ancient sediment, then turned into graphite, which allowed the plates to become a lot more brittle and to slide with a lot more ease. In other words, one of the reasons for the success of plate tectonics on our planet seems to be really because of this organic carbon inside the crust of our planet. And all of this, once again, being a result of ancient life that used to exist on our planet approximately 2.5 billion years ago. But the vast majority of these changes as you can see from this graph, began approximately 2 billion years ago, which directly correlates with the time when a lot of different plankton and bacteria began to add huge amounts of graphite into the ocean floor, thus becoming sedimented and then moving lower and lower into the Earth's crust. And this graph is important because it shows you when the carbon deposits were actually followed by formation of mountains. And notice how in pretty much every single case, or in most cases, in all of these 20 different mountain ranges, the sedimentation that was basically ancient life depositing as carbon into the plates was almost directly followed by a formation of mountains within about 100 million years. And even the most recent formations of mountains, including the Himalayas, seem to have followed a very similar pattern. In case of the Himalayas, for example, this process of thrusting was actually focused on a lot of the sediments from extremely organic rich beds that were created by a lot of this ancient life. And if correct, this is a huge discovery. It basically implies that the biosphere and the life on our planet is directly responsible for the geology of the planet as well. Or in other words, it establishes a link that nobody knew existed until now. And on top of this, all of the mountain ranges in this case contain huge amounts of graphite that was definitely produced by ancient life, which of course gives this idea of all of this being biological in nature a little bit more credibility. Although in this case, it's really the presence of ancient marine life. It was the ocean organisms that allowed a lot of these mountains to form millions and even billions of years after their original success on the planet. In other words, another way of looking at this is, well, these are basically the monuments of their success on our planet millions and billions of years ago. But naturally, monuments produced by physics, produced by geology, and produced through the interaction of various plates because the life made them slightly more slippery. But this is of course something that's still happening on our planet today and will continue going on until the plate tectonics finally stop. And interestingly, in terms of the actual composition, or at least the percentage of carbon by mass compared to some of the other rocks nearby, it doesn't even require that much carbon. The mountain ranges produced by this effect only required about 10% to maximum about 20% of carbon by mass. All of the mountain ranges investigated in the study only had approximately 10% of graphite by mass, with certain mountain ranges having it up to about 20%. And that means that a relatively small amount of biomass is required on a planet in order to produce all of these monuments, all of these mountains. And this is of course really important because one day we might be able to discover something similar on some other exoplanet out there. We might find mountain ranges, and that would be a really interesting sign of potential discovery of historic life on those planets as well. And so, for example, discovering a planet with plate tectonics and of course a lot of mountains on the surface is maybe a telltale sign that something similar happened there as well. So geological formations as signs of potentially successful life in the past is technically a really important discovery and something that we can use even in our own solar system. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries in regards to helium. That other gas that's just as important as hydrogen when it comes to studying cosmology and when it comes to studying the universe. But in this case, we're talking about this relatively recent study that discovers primordial helium here on Earth and calculates how much of it there is inside planet Earth. In the process, proving something really important about the formation of our planet. And so let's discuss this in a little bit more detail, but first let's start with the idea of helium and how it's not really just one single thing. There are different types of helium, or to be more exact, there are different isotopes of helium, 9 to be more specific, and 2 of them are stable. They can exist for as long as the universe can exist. Today they're known as helium-3 and helium-4. Now, the helium that's familiar to all of us, the one used in balloons for example, or the one that you sometimes hear in the news is becoming more scarce, becoming more expensive, and is slowly escaping into outer space from our planet, is helium-4. That's the most abundant helium type on our planet, and it's also the type of helium that's most used in various industries and a lot of different types of manufacturing. It's also the type of helium that becomes what's known as a superfluid when cooled down to extreme temperatures. In this case, it starts to behave using various quantum properties with the fluid literally being able to escape any container. And at the same time, it also becomes what's known as a boson. But that's beside the point. The point here is that this helium is different from what's known as helium-3, sometimes known as the primordial helium, because that's the helium that most likely was created during the Big Bang in the beginning of the universe. And unlike helium-4, helium-3 is pretty much a completely different element. First of all, it's the only element known to us that's stable and that has more protons than neutrons. Second of all, it's extremely rare on our planet. The vast majority of helium-3 on our planet came from the Big Bang, came from essentially the beginning of the universe. And it's also extremely rare on our planet. Of all of the helium on our planet, only 0.0001% is helium-3. Everything else is helium-4. And that's mostly because of how these different elements are made on our planet and how they are replenished with time. Apart from the original helium-3 from the beginning of the universe, a very small amount of it is also produced through the interaction of lithium that you see right here with a lot of natural neutrons coming from outer space or from planet Earth, with other small amounts being created during the so-called atomic age when a lot of different atomic bombs were tested in the atmosphere. But the production of helium-4 is different. It's produced by any type of alpha decay, or any kind of a radioactivity where an alpha particle emerges when some kind of a radioactive element decays. And so all kinds of radioactive elements inside our planet produce helium-4, and eventually it makes its way to the surface, although sometimes it stays mixed with a lot of other gases until someone goes and tries to mine those gases. So most of the helium-4 today is actually a byproduct of natural gas extraction. And as a result of all of this, there's so much more helium-4 compared to helium-3 on our planet if you were to compare it to a typical gas cloud somewhere out there in our galaxy. A typical cosmic cloud or a typical molecular cloud would actually contain much higher concentrations of helium-3 to helium-4 because of the way these two different isotopes are generated. So helium-3 levels in outer space are way higher. But in terms of usability for future technologies, it's really always been about helium-3. And there's a really important reason for this. A lot of theories predicted that by mixing helium-3 with deuterium, and by placing all of this in a typical fusion reactor with very high temperatures on the inside, it might become possible to create a source of extremely efficient and relatively safe energy, fusion energy. And in this case, helium-3 plus deuterium provides the best source. It's actually better than anything else we've ever studied or anything else we have. And in this case, it would produce the highest amount of energy and would produce almost no dangerous radiation at all, making helium-3 potentially one of the most important gases on the planet, assuming of course fusion technology becomes a reality. Now we're actually going to discuss some of the new discoveries in regards to fusion in one of the future videos, so make sure to subscribe, but there's also another video somewhere right there or in the description that discusses some of the recent achievements. Either way though, fusion is extremely important, and the ideas of fusion, almost all of them, rely on efficiency. And in this case, helium-3 atoms represent the most efficient types of fusion we can ever expect to achieve, but at the same time, its rarity represents the major problem with this element. There's very little of helium-3 on our planet, and the majority of the element is actually trapped inside. And every year, very little of it escapes. Approximately 2 kilograms per year usually seeps through various cracks here and there. And so because it's so rare on our planet, it's really only been used in very tiny, minute amounts in various research and nothing else. It's almost impossible to make this practical. But that's of course until the scientists realize that there is a deposit of helium-3 somewhere nearby. A tremendous amount of helium-3 is deposited on the surface of the moon by our sun. And that's because the nuclear reactions inside the sun also create helium-3 as a result. And all this helium-3 at some point makes its way to the surface of the moon and gets deposited in various locations, as you see in this image right here. And so there's actually at least 1,000 times more helium-3 on average on the surface of the moon compared to the surface of planet Earth. And it's still rare, but there's way more of it in certain locations. In terms of the actual numbers, some of the highest concentration of helium-3 on the surface here is approximately 4 parts per billion. That's pretty low. On Earth though, it's even lower. It's about 5 parts per trillion in our atmosphere, making this one of the rarest elements on the planet. But it's still an important element for other reasons, specifically understanding the universe and also understanding the origin of our planet. And so this recent study kind of investigated that. They wanted to figure out how much of helium-3 there is inside a planet, how it's being exchanged, and what all of this means for the origins of our planet in regards to the formation of the solar system. And so by doing a relatively thorough analysis of the structure of our planet, and by trying to figure out how much of helium-3 escapes the planet from the surface, in this study the scientists determined that the majority of helium-3 from the origins of the universe are very likely stuck inside the core of our planet. And through the process of convection and interaction of different layers inside our planet, some of the helium eventually escapes from the core, makes its way to the mantle, and then makes its way to the crust, escaping the planet at some point. With roughly around 2 kilograms, as I mentioned before, escaping every single year. And that's not a lot. But it also means that if we were to combine all of the helium-3 inside the planet into one large chunk, it would be roughly around 1 billion tons in mass, equivalent to about 200 pyramids of Giza in weight. Now all of this is of course based on modeling and mostly different calculations, so it's not actual measurements, but if correct, these measurements suggest only one thing about the origin of our planet. It suggests that Earth had to form inside a very deep region of solar nebula, or inside the thicker part of a molecular cloud where there is usually a lot of helium-3 present. In other words, it could not have formed somewhere on the outskirts or somewhere where there is not a lot of primordial gas. The high amounts of helium-3 present inside the core of our planet, and the large amounts of it escaping from the surface, suggests that the entire solar system and Earth inside the solar system were definitely somewhere in the center of this molecular cloud, with large amounts of helium-3 present inside of it as well. And it was also most likely formed during an extremely active phase of this molecular cloud, where a lot of stars and planets were being formed. So kind of like what we usually see in a very active molecular cloud nearby, such as the ones right here located in the Carina Nebula. Hello info person, this is Anton, and well, there's a dinosaur behind me, I think. And that's because today we're going to be talking about some of the new discoveries about the asteroid that ended their reign on the planet. And more specifically, a completely new asteroid, the one that we never knew about. Because very recently, and actually just a few days ago, the scientists have identified a completely new crater nobody knew existed. A crater that was created around the same time as the one that ended the reign of dinosaurs. And a pretty big crater, approximately 10 kilometers across. And if you're asking yourself why is it that nobody has ever seen it before, well, it's because it's actually in the ocean, located somewhere right here in the Atlantic between South America and Africa. And so let's actually talk a little bit more about this, including some of the other details and other discoveries from the last few years that help us understand what exactly happened 66 million years ago in order to transform the planet so much that the dinosaurs more or less disappeared and mammals, like you and me, became the dominant species. But first, a quick side note. This is not the first time we discover an additional crater from the same period of time. As a matter of fact, approximately a year ago from when I'm making this video, we've actually discussed the previous discovery of the Blobs impact structure located somewhere in Ukraine that had all of the additional signs that very likely hit planet Earth a few thousand years after the initial impact in Mexico. And although the Chicxulub crater was obviously the biggest and the most powerful impactor, it looks like there were additional impactors afterwards that, as some of the scientists speculated, essentially added to the total release of various gases on the planet, serving as an additional source of various emissions, which added to the survival difficulty of various dinosaurs and kind of sealed their fate. With the speculation here being that if it wasn't for these additional impacts, there might have actually been a chance that some of the dinosaurs, or actually a lot more dinosaurs, would have survived the initial impact. But because several events happened at once, including the volcanic eruption in India, all of these emissions changed the climate on the planet way too much, resulting in an extinction of several species all at once. And one of the ways that all of these impacts influence the planet is actually by suddenly releasing huge amounts of sediments, which basically released huge amounts of CO2, along with other gases on the surface of the planet, which basically transformed the oceans, acidifying them almost instantly, and also transformed the atmosphere, making the climate way too different compared to what it was before. I've actually discussed this in many other videos, and you can find some of them in the description below. And one of the other recent videos from just a few months ago also mentions an incredible discovery of what appears to be oceanic ripples from massive tsunami waves created around 66 million years ago, with the origin of these waves being the massive crater in Mexico. The video about this is also in the description below. And so in the last few years we've actually learned quite a lot about that one day when all of the dinosaurs sort of perished, or I guess most of the dinosaurs. There is of course the speculation that certain birds evolved from dinosaurs, but genetically speaking birds are extremely different from dinosaurs, and I guess that idea deserves its own video. And so we've learned so much in just the last few years. There's even at least one study that claims to have discovered potential DNA of an ancient dinosaur, something that would actually be quite groundbreaking. And now we have a new discovery. A discovery coming from the ocean. And as you probably know already, we actually know so much less about the ocean than we do about other planets. As a matter of fact, we have better maps of Mars and the Moon than the Earth's ocean. But in the last few years, the scientists have been actively trying to map all of the ocean and have actually been creating incredible new maps by using new technologies. Although in this case, the technique itself is pretty old, but the way that it's used is completely new. So this is known as the reflection seismology, something that was actually used back in the early 1900s. And the idea is to create some kind of a vibration or some kind of a shock that will then create waves which can then be detected and measured from elsewhere. So in a sense it kind of works like a sonar, except that in this case the sonar or the waves go through the Earth itself and through the crust. With this right here being one example of the data that it produces. But naturally now we have so many new techniques and actually really interesting techniques. For example, these machines right here are able to produce the vibration by hitting the ground in just a specific way, which then allows the scientists to create these very beautiful three-dimensional maps of what happens underneath. But in order to do this in the ocean, the scientists use something a little bit different. They use a high-pressure air bubble that shoots into the water every 15 to 20 seconds. And so it acts as a kind of an air gun that releases these very high-pressure bubbles at very regular intervals. And so by conducting this technique right here around the west coast of Africa, the scientists identified telltale signs of an ancient crater, although in this case covered by huge amounts of sediment, mostly because this happened 66 million years ago. And actually that's exactly how the scientists know the age, because of the amount of sediment. Although I guess a quick side note, it's still an estimate, so in order to establish the exact date, the scientists would have to get one of the samples. This cannot be done just yet, you would have to drill through all of this in order to collect at least one of the samples. But the signs were all there. All of the rims, all of the peaks, everything that we expect from a typical crater created by an asteroid was all visible in this case as well. And so they named this the Nadir crater, named after the nearby volcano known as Nadir Seamount. And if you actually wanted to find out where it is on, for example, Google Maps, you can grab these coordinates right here from Wikipedia, and then by putting them into the Google Earth or Google Maps, you'll discover the approximate location. So it's somewhere right here. And it's supposed to be about 10 kilometers in size, so it's maybe about this big. Although as you can see here, we don't really have the very accurate maps of this region. So it might be actually somewhere here, but it's naturally very difficult to see because the maps here still lack any detail and these areas have barely been explored. And so it's somewhere right here, very close to Guinea. And if this impact is confirmed by other studies, it would make it an extremely interesting discovery, because this is one of the few marine impact craters that would be officially confirmed and are known to exist. Although based on the current data and current observations, it almost certainly is one. But I guess the next question is, what exactly caused this, and where did it come from? Well, in terms of what caused this, the scientists can work this out, mostly based on the modeling from a lot of other similar events and from a lot of computer simulations. In this case, it's believed that this asteroid was approximately 400 meters in diameter and hit the water at approximately 20 kilometers per second. And because the ocean here is not super deep, it would very likely go through the water column and strike the upper crust of the planet as well. And so all of this would result in, first of all, a huge water column, or basically kind of like a tsunami, that's at least 800 meters in height, but also a huge amount of water simply evaporated almost instantly. And when it hit the ocean floor, it would also create a very powerful earthquake, very likely 7 in magnitude, which potentially then creates tsunamis and even landslides, resulting in even more destruction around the area. There would also be a huge air blast and a huge explosion with one of the loudest sounds ever, with the overall energy released being approximately 1,000 times larger than the eruption of Tonga that happened in 2022. At least that's what the scientists were able to simulate using relatively accurate models, and the actual results look extremely similar to what they found underneath. And interestingly enough, in terms of the size and in terms of the profile, this asteroid is not so different from the asteroid Bennu that NASA recently collected the samples from. As a matter of fact, Bennu right now is one of the more dangerous asteroids out there in terms of the potential collision with planet Earth. And we believe that collisions with very similar asteroids, approximately 400 meters across, very likely happen at least every 100,000 years, with at least a few similar-sized craters already identified in the last few years. But the other question is this particular asteroid related to that crater from Mexico, related to the bigger one? And is this somehow also related to the crater from Ukraine? Since the age of these asteroids is relatively similar, within about 1 million years, the implication is definitely there. Were these asteroids just part of a larger family that essentially collided with our planet over a period of 1 million years, eventually resulting in the demise of a lot of life on the planet? Well, right now the scientists believe there are 3 possible explanations. The first explanation is that maybe they did have some kind of a parent asteroid that broke up, creating several fragments, with all these fragments then coming to the planet and eventually resulting in several collisions, with 3 detected so far. Which would also mean that the extinction event itself did not just happen because of that one collision, but it happened because of a series of events that unfortunately happened around the same time. Several collisions, plus the volcanic eruption in India. You can learn more about all of this in some of the videos in the description. We've actually observed something similar, but on a smaller scale, happening on Jupiter back in the 90s. The Shoemaker-Levy 9 comet that broke apart and hit Jupiter in several locations could be a potential model for what happened here on Earth. And the signs of the collision here were actually visible for quite a long time afterwards. You can see them in these pictures. But in this case, the comet fell apart because of the tidal forces, not really because of a collision, and it's kind of unlikely that this would happen around planet Earth, mostly because our planet is just not massive enough to create such tidal effects for comets or asteroids coming from distant locations. But this could have been actually created by a collision with a larger asteroid somewhere in the asteroid belt that essentially created a bunch of pieces that then ended up coming closer to planet Earth. And if so, chances are there might be more pieces somewhere out there, or actually there could have been more pieces colliding with other objects, including the Moon or possibly even planets like Mercury, and we should be able to find some of the craters around the same time by looking at surfaces of these objects. Although at the moment it's actually a little bit difficult for the scientists to identify the exact period when some of these craters were made. A lot of this is still based on statistical analysis, and a lot of it is based on estimates. Back in 1988, somewhere in the province of Quebec in Canada, there was an unusual pink-purple globe detected flying above the St. Lawrence River. An object whose nature and whose origins were unknown for many years, technically still unknown today. And although initially it was obviously assumed to be some kind of a UFO or potentially some other mysterious and hard to explain phenomenon, eventually it was followed by something else. It was followed by an earthquake. And this is where our story begins. Hello wonderful person, this is Anton, and today I wanted to talk about this really interesting concept that's technically becoming an actual scientific concept simply because of the amount of evidence that seems to suggest it actually exists. And no, we're not talking about UFOs, mostly because I still think it's nothing to do with science. We're talking about something way more interesting in my opinion. We're talking about earthquake lights. These strange phenomena that seem to appear during very powerful earthquakes and that in theory could actually explain various UFO phenomena as well. And one of the main reasons why it was very difficult to believe the phenomenon existed was actually because of the poor quality of various pictures. For example, here's a picture from Romania from the 70s. This is a courtesy of Seismological Society of America. What exactly is this showing us? It's showing us something, but it's hard to actually distinguish anything here. On the other hand, this picture by Jim Conacher taken in Alaska in the 70s shows us something with slightly more detail, unusual yellow lights above a lake. But in this case, it's still kind of difficult to explain what exactly we're looking at, or even if this is a real phenomenon. But both of these phenomena were followed by a relatively powerful earthquake. But the reports of these lights appearing after earthquakes actually have a very long history of being reported in a lot of different literature. As a matter of fact, the first ever mentioning of an earthquake light was back in 869 in regards to a relatively powerful earthquake in Japan. But more and more reports start to come out in the 20th century, and way more in the 21st, especially with the advent of CCTV and various smartphones that do have much more powerful cameras. And in every single case, it would involve some kind of a relatively powerful earthquake, at least 5.5 on the Richter scale. And the interesting thing is that usually these lights were classified as either one of the two. Either unusual globular formations usually flying above the area where the earthquake would occur eventually. This is something that happened back in 1975 in Hawaii. Or the lights generally resembling a typical aurora, but usually white or blue in color, with the lights themselves appearing and disappearing in just a few seconds, occasionally lasting for a minute or so. And so, for example, in 1930s, once again in Japan, there were lights that were visible from a distance of about 110 kilometers. But more recently, the devastating 2008 Sichuan earthquake produced lights that were visible from approximately 400 kilometers away. None of this was recorded on camera, or at least not reported by media, but it was reported by several witnesses. Similar phenomena were seen in 2003 earthquake in Mexico, in 2007 earthquake in Peru, 2009 earthquake in Italy, 2010 earthquake in Chile, and even the powerful eruption of Sakurajima volcano also resulted in the production of these lights. Or at least that's what was claimed by the eyewitness accounts. And up until about 10 years ago, most of the scientific community was still relatively skeptical about the existence of this phenomenon simply because it seemed a little bit unrealistic. How exactly would a light be produced because of the earthquake? Yet more and more reports started to come out, and with the advent of social media and more importantly smartphones, we started to get actual evidence, video evidence. Now at first it was just photos, once again showing us unusual lights. For example, this is from 2009 in Italy, with certain pictures and videos not really showing much, and certain other pictures looking a little bit too unreal, even though these were actual photos. But then we started to get actual footage from actual witnesses using smartphones. And this is absolutely incredible. This shows you what these earthquake lights were like during an earthquake in 2021 in Acapulco, Mexico, with these phenomena being captured from a lot of different angles by a lot of different people. And some of them just being completely unreal. It literally looks like the entire sky is exploding with these lights. Now what exactly is happening here? And more importantly, is this an actual real scientific phenomenon? And of course not everyone believed what they were seeing. Well, some of the explanations for these lights do make sense. These were maybe exploding transformers. As a matter of fact, at least one video from Acapulco that you see right here, and as always you can find in the description below, shows us what happened right there. This transformer exploded, producing the lights above. But this single explosion doesn't actually produce enough light to illuminate the skies just as we see behind it. So something else, more powerful, was causing a lot of these other flashes. For example, in this case right here, the actual light seems to be coming from above the skies, not really from below where the transformers would be located. Similarly, in this video right here, it becomes obvious that some of the lights also seem to be different color, so they do seem to have slightly different origin. And so following this earthquake last year in 2021, that's sort of when a lot of scientists suddenly realized that maybe this is something after all. And specifically because even very recently, both in China and in Japan, we had even more evidence for the existence of these unusual earthquake lights. These lights you're about to see, that's from the very recent earthquake in the same region of Sendai in Japan, with this video being taken on March 16, 2022. And as you can see from the power of this flash, it's unlikely to be a transformer. Something way more powerful would have to produce the light we're observing. But that's where we enter the realm of unknown. At the moment, it's really unclear what produces this. But from all of the available evidence so far, some of the scientists established that it seems to be possibly two different phenomena. One of them, resembling a typical aurora, usually happens either during or slightly after a very powerful earthquake, at least 5 on the Richter scale. But then there is also something that seems to happen before the earthquakes, sometimes even a few weeks before the earthquake occurs. And this is something that's observed very close to the epicenter. And sometimes this resembles a ball of light, sometimes it resembles something slightly different, but it seems to resemble a typical object we would classify as a ball lightning, or sometimes resembles a ball of light that hovers and disappears slightly after. So yeah, it sure sounds like a typical UFO, but a lot of these events seem to be pretty much natural. But aliens, they're not. because there are actual scientific explanations for what could be possibly happening here. It's just not entirely clear which explanation is the best. For example, in one of the explanations, it involves a chemical reaction. In this case, through the breaking of different bonds inside certain minerals, for example dolomite or rhyolite, it's possible to produce very high stress that can then release oxygen that actually becomes ionized. And once these ions escape from the cracks in the rocks, they can then start ionizing the atmosphere, forming plasma that emits light. Actually, the plasma ball you see right here is produced in this way, with certain experiments in the lab suggesting that this could actually explain some of these phenomena. So for example, by having certain locations with relatively vertical folds or cracks, this in theory can produce a lot of ionized oxygen, thus producing a lot of light. But that's of course just one of the explanations. The other explanation involves the principle known as piezoelectricity, the same principle usually used in a typical quartz clock. And here, through the mechanical motion on the quartz crystals and through sheer power of the earthquake, this can actually produce a lot of electricity, which once again could maybe produce some sort of a ionization in the air. Another explanation involves the magnetic field of our planet, and specifically the interaction between these very highly electrically charged rocks and the magnetic field above the region, with these regions then triggering some kind of a Aurora-like event. And the last explanation involves a phenomenon that we know exists but also do not understand. This is known as the triboluminescence. It's the unusual production of light when certain minerals, in this case once again crystal, are mechanically pulled apart, ripped, scratched, crushed or rubbed, and end up producing the light that you see right here. And so trying to use this phenomenon that we barely understand to explain another phenomenon that we really don't understand is not really good science. But nevertheless, it is one of the possible explanations for how some of these lights that have been observed in various regions on the planet seem to be produced. But even though we don't understand what's happening here very well, we do understand where these events seem to occur. The vast majority, or about 97% of all of these lights, for the most part have been associated with these so-called subvertical faults. The regions which only cause about 5% of all of the earthquakes on the planet, and essentially represent a region where the tectonic plates are stretched and pulled apart, causing various vertical cracks. In contrast, the majority of earthquakes on the planet are usually caused by the subduction zones, where one plate is slipping below the other. And so knowing where these earthquake lights happen could one day help us figure out what's happening here. Hello wonderful person, this is Anton, and today we're going to be discussing our planet, planet Earth, and the history of some of the most massive mountain ranges, how they influenced our planet, and more importantly, what the future mountain ranges might look like in the next 200 million years. And more specifically, we'll discuss the concept that the geologists usually refer to as super mountains, the mountain ranges that are generally much larger than anything we have right now, and some unusual effects they actually have on the planet, including the evolution of life on the planet. And let's actually start with that. So historically speaking, when it comes to studying our planet, we know that because of the plate tectonics and because of various activity on the surface, the actual surface of the planet and the mountain ranges changed quite dramatically in the last few billions of years. But there were several times in history where something known as a supercontinent would form somewhere on the planet. A supercontinent in this case would refer to one single large piece of land surrounded by a relatively large ocean, with the most famous one, the one you see right here, known as Gondwana. This most likely formed around 550 million years ago, but then started to fall apart around 180 million years ago, turning into several continents we have today. You can actually explore this yourself using this beautiful simulation from Ian Webster, the link for which you can find in the description below. And because of the plate tectonics and the way that the continents interact, generally when you basically have a lot of continents fall into one single piece of land, they'll actually start forming extremely large mountain ranges, even larger than anything we have today. And that's mostly because of these so-called continental convergent boundaries, where essentially two plates start colliding with one another, producing really large mountains on top. And generally these mountain ranges can grow for a pretty long time, several 100 million years sometimes. But they don't last forever. As a matter of fact, all of these ancient mountain ranges are long gone to erosion and to a lot of other effects on the surface of the planet, with the action from the wind, water, and other forces basically making it fall apart with time. But by using some of the modern mountains and looking what's inside of them, the scientists today can generally figure out what sort of mountain ranges existed in the past through studying various types of elements and through specific minerals that we find inside of them. For example, zirconium or zircon crystals, which are normally used in some of the cheaper jewelry, are often used in these various studies. And that's because these types of minerals are only formed in extremely high pressures below some of the heaviest mountains on the planet, but can usually survive most of the erosion that affects the rest of the mountain. And the precise composition of some of these zirconium crystals can generally reveal the specific conditions where these crystals were made. For example, by finding some kind of a zirconium with relatively low amounts of what's known as lutetium, a rare earth element, it's generally believed today that these types of zirconium crystals can only be formed at the base of an extremely high mountain, with one of these studies in the description below discovering at least 2 times in history where this types of zirconium was actually made in relatively large amounts, suggesting 2 major mountain range formations with some of the highest mountains that ever existed, supermountains, something that no longer exists anywhere today. And these would be at least 3 to maybe even 5 times larger than the modern Himalaya mountains. So essentially we're talking about something that's thousands and thousands of kilometers in size. This is one of the NASA images of the Himalayas. And it just so happens that the first spike was detected around 650 to maybe 500 million years ago, and it's very likely related to the Gondwana supercontinent you see right here, with one of the mountain ranges maybe being somewhere here. But most interestingly is the fact that this particular supermountain appeared approximately 40 million years before an extremely important event in the history of the biosphere. The event we refer to as the Cambrian explosion, where a lot of really complex, really unusual multicellular animals appeared on the planet and existed and interacted with one another for millions of years. This was actually one of the most important evolutionary events that defined how life evolved later on. And the scientists believe that this is actually connected. They believe that these supermountains, as they became eroded over millions of years, as they eroded, introduced a huge amount of various nutrients into the oceans on the planet, allowing the life to evolve really quickly. In other words, by breaking apart these really large mountains, suddenly there was a tremendous amount of nutrients in the water, with these so-called Gondwanan supermountains very likely being the cause of all of this, at least according to the scientists in this paper. But in this case, they believe it also happened sometime before that, because another supermountain range existed roughly around 2 to possibly 1.8 billion years ago. A mountain range that's sometimes referred to as the Nuna supermountain, with this mountain range very likely being at least 8,000 kilometers long and also being part of another supercontinent. But this is when life was mostly bacteria and various types of archaea. It was actually really simple. Although the scientists in this case believe that these mountains, as they also became eroded and fell apart, introduced all of the necessary components to once again help life evolve into something different. And in this case, evolving from prokaryotic simple cells into eukaryotic, more advanced cells. So they actually believe that the evolution of eukaryotic cells might have been dramatically increased and encouraged and possibly even caused by erosion of these supermountains from 2 billion years ago, with the introduction of elements like iron and phosphorus into the oceans being the biggest addition to the water, which most likely increased the evolution rate on the planet, while at the same time possibly also changing the atmosphere and maybe even releasing oxygen into the atmosphere as well. But more intriguingly is the fact that in between these two supermountains, in between 1.7 billion years ago and 750 million years ago, not much happened in terms of mountain formation on the planet according to modern studies. And today geologists refer to this period as boring billion, mostly because during that period not much evolution happened on the planet either. The life remained more or less the same, with the implication being that supermountains might play a very important role in helping life evolve really quickly. or at least play a very important role in enriching oceans and the rest of the planet with a lot of nutrients from the erosion of these very large mountains. And when it comes to these supermountains, it's also sometimes interesting to see into the future, to try to predict how the evolution of the planet will transform and change in the next few hundreds of millions of years. And in this sense, today the scientists actually have a lot of different tools to play around with that create various rules for how the planet is going to be evolving in the next few millions of years and how the continents are going to be moving around. And at least one such study that, as always, you can find in the description below, decided to take this a little bit further and find out when the next massive mountain range is going to be formed as well, and where exactly it's going to be located. Although in this case it's not truly a supermountain, it's just a relatively large mountain range, possibly similar to the Himalayas, which are no longer going to be around by the time this comes into play. And so here, all of this is based on the simulation using the modern rules of the evolution of plate tectonics. And it looks like in approximately 200 million years from now, there's going to be a really large mountain range, once again in the region where India is located. And the scientists refer to this particular mountain range as the Somalian Mountains, mostly because it's made out of Somalia, and it also seems to be in the location where Himalayas are as well. And being able to predict the future mountains in this case could actually help us understand where our planet is headed and what sort of climate we can expect in the future. And we're talking about really far future. And in this case, this mountain belt is very likely going to be formed between the region between Madagascar and Africa, and it would very likely also be strongly curved. It's not going to be straight, with the northwest part of India being completely buried by Somalia, but later on re-emerging as Somalia rotates and exposes this region, with scientists comparing this to what most likely happened in western Norway around 400 million years ago. The large mountainous regions in Norway were formed in a very similar way. But obviously here we don't really know exactly how this is going to play out, and this is just a preliminary discussion based on the modern understanding of plate tectonics. Hello wonderful person, this is Anton, and today we're going to be discussing the history of the magnetic field on planet Earth, and actually discuss something that happened on our planet a few 100 million years ago when the planet almost completely lost its magnetic field, which at least in theory would have led to Earth becoming uninhabitable, or at least somewhat similar to planet Mars. But it didn't. The magnetic field then restored itself within approximately 15 million years, with the magnetic field returning to its original strength. So what exactly happened here, and why exactly did Earth not become like Mars? Why did our planet remain like this, while Mars only now has these pockets of magnetic field existing on its surface? And so this new study explores this in more detail and might have actually discovered what happened to planet Earth, while also discovering this other thing that makes our planet so lucky enough to maintain necessary conditions for life for a long period of time, and lucky enough to produce us. So what exactly happened here? Well, first of all, when it comes to the existence of the magnetic field, the early investigations point at the existence of the field as far back as 3.5 billion years ago. In other words, our planet might have actually had the magnetic field for a very long time. And the scientists today believe that the field itself is generated by the active dynamo inside the outer core of planet Earth. Or in other words, the liquidy part just above the inner core that seems to circulate a lot of liquid metal and a lot of metallic materials, and as a result produces the magnetic field that preserves life on the planet. But a lot of modern studies also discovered that approximately 500 million years ago, during the Cambrian period, the period that's also famous for the evolution of a lot of really strange, complex life on the planet, the magnetosphere of our planet almost completely collapsed. And specifically, approximately 565 million years ago, the magnetic field of planet Earth suddenly became approximately 10% of its original strength. Something that, at least in theory, could have completely destroyed the possibility for future life to evolve and for life to exist on the surface. In other words, historically, there was actually a time on planet Earth when it could have sort of become the new Mars. it could have slowly dried out and lost all of its water and potentially even atmosphere, because the magnetosphere would no longer be able to protect the planet from the very powerful emissions coming from the sun. But something else started happening 515 million years ago, approximately 15 million years after. The magnetic field suddenly started to restore itself to its original values, and it maintained the strength for the past 550 million years. Which of course suggests that something must have happened to our planet approximately 550 million years ago in order to restore the field and in order to, once again, allow the life to evolve and to thrive on the surface of the planet. And the question is what? What happened to planet Earth 500 million years ago to make it so lucky to evolve complex life on the surface? And it's not an easy question to answer. To answer this question, the scientists behind the paper you can find in the description below had to use a lot of samples and conduct a very thorough investigation using various types of minerals such as anorthosite that you see right here that generally tend to keep a pretty good record of the magnetic field when these minerals were originally formed. All of this is possible because of the deposits of magnetite inside the rocks that tend to align themselves with the magnetic field of the planet, allowing the scientists to study the strength and the orientation of the field. And so in this case, the anorthosite samples discovered in Oklahoma that were created approximately 550 million years ago allowed the scientists to sort of discover the mystery of what happened to the field back then. And as a side note, this particular period on the planet is extremely important because that's the period when we had something known as the Cambrian explosion, the sudden explosion of a lot of strange multicellular life on the surface of Earth. And though it's not certain if this is somehow related to the magnetic field that seems to have been undergoing changes during that period, the correlation is still there. So what exactly was discovered here? Well, first of all, it's still kind of uncertain, but for some reason, approximately 550 million years ago, the field started to decline in strength. It's obviously not certain why yet, but it's possible that after 3 billion years of the existence of the field, something inside planet Earth might have actually decreased the temperature of the outer core, with the outer core now not circulating as much as before. And because of this, the field started to weaken and eventually almost completely collapsed. This is actually the same reason we believe Mars no longer has any field on the surface. But our planet did not suffer the same fate as Mars. Why not? So the scientists investigating the rocks discovered that the field started to strengthen around the same time as the sudden appearance of what we refer to as the inner core, the relatively large solid chunk of metal that's essentially right in the middle of planet Earth. And though it's not entirely certain when inner core started to form, a lot of recent studies do point at that period approximately 550 million years ago, meaning that prior to that, the planet only had liquid core, with the inner core simply forming because the planet started to cool down and the liquid metal on the inside started to form a solid deposit. But here's the super intriguing part. As this tiny chunk of solid metal developed inside the planet, it actually started to influence the outer core in a very unusual way. A lot of modern simulations and a lot of modern studies determine that the inner core, which today is basically a solid ball approximately 1200 kilometers across, or about 70% of the moon's radius, actually enriches the outer core in oxygen as the iron on the inside crystallizes. And by doing so, it dramatically decreases the density of the rest of the outer core, which then increases the circulation and the motion inside of it. In other words, the dynamo itself is to some extent caused and forced by the inner core and by the crystallization of iron. Or in more simpler words, as the inner core grows in size, it sort of forces the outer core to circulate more and thus maintains the magnetic field. And it does so by creating these convection currents, which are believed to be the primary driver that produce the magnetic field. And so what the scientists found here was that it was an unusual coincidence. When the Earth's magnetic field started to weaken, suddenly the formation of the inner core restarted the activity within just 15 million years, allowing the planet to restore its magnetic field in a very short period of time. And so the formation of the solid inner core completely recharged the magnetic field in just 15 million years. But by studying these rocks, they also discovered that approximately 450 million years ago, or 100 million years after the magnetic field was restored, the inner core might have changed its structure once again. it formed an unusual boundary between the innermost and outermost inner core. And in this case, the scientists think that it might have happened because of the activity of various continents and plate tectonics on the surface of the planet. Now, this particular discovery was discussed in more detail in the previous video that should be in the description or somewhere right there. But more importantly, this once again confirms that the inner core seems to possess two parts. So it's not just one chunky ball. But what exactly these two parts do and how they affect the planet is not really certain. Although I guess what's somewhat intriguing here is that it looks like the activity on the surface of the planet seems to affect some of the activity inside the inner core. With all of these discoveries being very important in our attempt to understand how exactly life survived on the planet for so long, and how various types of complex life then managed to evolve on the surface of the planet. All of this seems to be connected, because obviously if the magnetosphere of our planet did not survive for such a long time, there is no way the life would have been able to survive on the planet for so long either, at least complex life. If it wasn't for the magnetosphere, the planet would have become dry pretty quickly and would have lost its atmosphere a long time ago, becoming yet another planet Mars, or similar to Mars, which kind of adds to this really intriguing idea known as the rare Earth hypothesis, the idea that our planet might have experienced several really lucky events, with one after another leading to the formation of really complex life on the planet that actually would be practically impossible anywhere else in the universe. And based on some of the recent observations, really complex observations for many decades, and also based on this study and a lot of other studies, there's now more and more proof that, well, for one, life might be super rare in the universe, at least when it comes to complex life. And even if some life can exist elsewhere, it's a lot more likely to be extremely primitive and would not really have a chance to develop into something complex because of these other factors that our planet was just very lucky with. And in this case, the magnetosphere is just one of them. No other planet, no other object in the solar system seems to have gotten so lucky and experienced these events in just the right way. Hello wonderful person, this is Anton, and today we're going to be discussing the magnetic field of our planet. And I guess more specifically, we're going to be discussing the idea behind the magnetic flip of the magnetic field of our planet, where the magnetic lines flip from north to south. Something we know happened in the past many times. As a matter of fact, previous studies have identified hundreds of such events by looking at various deposits and various sediments, where it becomes quite visible that the north used to be south and the south used to be north. Something that we know usually is preceded by a sudden weakening of the magnetic field, with the event itself very likely lasting for a few hundred years. Which of course suggests that during such an event, the magnetic field of planet Earth might actually disappear for at least some time. And because a lot of the modern technology directly depends on the existence of the magnetic field on planet Earth, it's actually something that we would like to understand and learn more about. It's one of the more important topics when it comes to studying planet Earth. But I guess the question is, what makes the scientists believe that the magnetic field could be potentially flipping soon? Well, there are two main reasons for this. One of them is in regards to the geological record of the planet in the last 200 years. The scientists determined that the magnetic field has weakened by approximately 9% in total. In other words, the field was about 9% stronger approximately 200 years ago. On top of this, there's a really unusual anomaly that's been forming in the South Atlantic region that you can sort of see as this black dot right there somewhere in South America. This is known as the South Atlantic Anomaly, and it's something that the scientists have known about since 1958. As a matter of fact, this particular black dot has already caused a lot of problems to a lot of different space missions. Now, some of them are not particularly dramatic, like for example the Hubble telescope is actually usually unable to take any pictures in this area and has to fly through it without doing any kind of science, but some of them have been a lot more dramatic. Although I guess the first question here is, how exactly is this formed? Well, today the scientists believe that it's because of the inner Van Allen's radiation belt that comes extremely close to the planet's surface, going down to an altitude of about 200 kilometers or 120 miles in this particular region. And because of this dramatically increases the overall radiation that a lot of satellites or any kind of a spacecraft flying through here will experience by going through the region. And on top of this, the overall Earth's magnetic field is also much weaker in this region as well. Moreover, it's been established that the overall field intensity in this region has dramatically decreased in the last 150 to 200 years. yet the overall area has increased by approximately 5 times. Which implies that this particular anomaly seems to be increasing in size but decreasing in strength, meaning that it's creating a kind of a magnetic hole. And even though it doesn't simply change in the southern part of the anomaly, it has been expanding to the northwest, to the north, and to the northeast. And because of this, since the beginning of the space age, it's actually created a lot of problems for a lot of different things. We're talking about things in space, including astronauts, including the International Space Station. For example, all of the astronauts that have spent enough time flying through this region have usually reported unusual white dots flashing in their eyes. They're sometimes referred to as the phosphenes or the astronaut's eye. More officially, they're known as the cosmic ray visual phenomena and are believed to be formed either because the cosmic rays are striking retina or maybe even neurons, or possibly because the cosmic rays are producing what's known as the Cherenkov radiation in the liquid of the astronaut's eyes. The actual mechanism is not understood completely yet, but we know that this is a fact and it's been observed by pretty much everyone, especially in this region. It also obviously implies that by flying through here, the astronauts are exposed to way more radiation than usual. And because of this, there are a lot of different measures ISS has taken over the years to protect the astronauts when they're in this area. On top of this, at least one satellite network known as Globalstar has actually completely failed back in 2007 because of this particular area and because of the extreme radiation that the satellites were exposed to. It was also reported that pretty much all of the computers on the space shuttle would usually crash and create a lot of errors when the space shuttle moved through this area as it approached the ISS. But one of the most expensive losses to date was the Japanese Hitomi satellite, which very likely started to fail as it passed through this area, with a lot of different devices failing afterwards. This was a really expensive mission, but it only lasted for approximately a month, and was supposed to be the most powerful X-ray telescope Japan would have ever launched. And so the growing South Atlantic anomaly, along with the overall weakening of the magnetic field in the last 200 years, presented the scientists with a bit of a concern. Is the magnetic field about to flip? Or are we about to experience what's known as the excursion, with the most famous one being the so-called La Chambre excursion that happened approximately 42,000 years ago. It's also sometimes known as the La Chambre event and is believed to have occurred for over a period of about 800 years. During that time, it's also believed that the magnetic field of the planet might have been actually completely gone. And during that time, the poles have also temporarily flipped, but then flipped back to the original position, with the field returning back to normal within approximately 1,000 years. Now, we've actually talked about this event in the past, and it's a very well-known and well-studied phenomenon, but what exact effects this had on planet Earth is not really understood today either. We do, however, have some really unusual correlation with this event. So approximately 42,000 years ago, that's when, for example, a lot of megafauna that used to be present on the planet started to disappear as well. Now, we still have no clear evidence that it happened because of the event, but the correlation is still there. Around this time, this is also when our cousins, the Neanderthals, went extinct as well. But more intriguingly, this is also when a lot of cave art appeared around the planet, with the implication here being that maybe the early humans were sort of forced to live in caves a lot more often because of the inhospitable conditions outside. Now, obviously, a lot of these are very big speculations, but a lot of scientists have been speculating about this for many years now, with some other speculations including the climate change in the North Europe and North Asia, and possibly a lot of other things that happened to the planet in those 800 years. In other words, whatever happened on the planet during that time was very likely not good for life on the planet. And so, are we headed for another one? That's basically the big question here, because the signs from the anomaly and from the weakening of the field kind of imply that. But the recent study argues against that, and actually that's not the only study out there. Many studies today have finally figured out that chances are we're not actually headed for any kind of excursion or any kind of a flip. And here's why they think so. So first of all, a very wide paleomagnetic record has officially showed us that the magnetic field of the planet right now is much stronger than it's been in the last few millions of years. It's only weakened by a little bit in the last few hundreds of years, but when comparing this to the field from approximately 100,000 years ago, it seems to be very strong, and it's actually twice as strong as 1,000,000 years ago. So in other words, even though the field might have weakened by 9% in the last 200 years, overall it actually strengthened dramatically over the period of 100,000 years. Okay, but what about that South Atlantic anomaly? And so that's exactly what this new study focuses on. The scientists here realized if they can actually find more of these anomalies in the last, let's just say, 9,000 years, it might help us understand that this is something that just generally happens to our planet. And that's exactly what they did. They collected a lot of magnetic record using, for example, pottery that usually contains signs of the magnetic flips and magnetic reversals, or just generally allows us to even measure the magnetic field in the past. They've also looked at the deposits from various sediments and various volcanic rocks on the planet, and determined that overall, in both North America and Middle East and Europe, the magnetic field did actually change quite a lot in the last 9,000 years. But more importantly, they did discover at least one other similar anomaly that happened somewhere in the region of North America and potentially also happened in the region of the Middle East. Or it could have actually been the same anomaly that sort of moved around and shifted around the planet over a period of several hundred years. And in terms of the actual size and strength of the anomaly, you can see in this image that it was extremely similar to what we have today in South America. The anomaly that was present in North America very likely started around the year of 1600 BC and lasted for at least 1300 years, disappearing almost completely within just a few hundred years afterwards. And I guess one of the more unusual and more interesting discoveries in this particular paper can be seen in this graph. It shows us that the strength of the field around the entire planet didn't just recover, but it actually bounced back to levels that were much higher than before, and stayed at these levels for at least a few hundred years as well. With this being a really important discovery, it means that whatever is happening in South America right now is not just a temporary event, it's very likely an event that's going to reverse completely, returning the magnetic field to normal levels, but then might even cause the magnetic field to strengthen dramatically, which might last for several hundred years. And so in other words, it really shows us that this is not an anomaly at all. It's just some kind of event we don't really understand very well, and it's something that very likely happens to our planet pretty regularly because of some unusual activity inside the planet. And this, by the way, could have a potential solution in another paper that we've discussed only a few months ago, or I guess maybe a few years ago, depending on when you're watching this video. The video itself should be in the description, but in a nutshell, not so long ago, the scientists realized there are these unusual magnetic waves that seem to be propagating inside the planet, very close to the core of the planet, and they seem to be doing so every 7 years. Kind of like these really large magnetic tsunamis that we still don't understand. And chances are that this is exactly what's causing these effects on the surface of the planet, but we obviously have no idea how any of this works just yet. Hello wonderful person, this is Anton, and today we're going to be talking about some of the new and more recent discoveries, and also somewhat surprising discoveries, about the phenomenon known as Aurora. Although in this case we're talking about a more unusual phenomenon that is often linked or associated with Aurora itself. A phenomenon that's sometimes referred to as the auroral sounds. A somewhat difficult to hear type of sound that's often heard during the aurora, especially the ones that are extremely strong. That has been previously compared to the sound of a waterfall, a kind of a popping and a crackling sound, and a sound resembling static electricity. In other words, there's no one description of this phenomenon, but it's been sort of reported here and there for many decades. But it wasn't until 2012 when the Finnish scientists have finally revealed the actual recordings of these sounds confirming their existence, because previously it wasn't really certain if they were real or if it was just someone's imagination. Which sort of relates to this other video from not so long ago in regards to the so-called earthquake lights. The lights that have also been reported for many years, but that have been previously thought to be maybe some kind of a folklore or just someone's imagination. You can actually learn a little bit more about this in one of the videos in the description. But unlike earthquake lights, the auroral sounds have been definitely reported and recorded, so this was a real phenomenon. But it just nobody really knew how exactly it works, and what exactly makes it happen, or even what produces it. And so the recent research finally explains it, and sort of suggests that it's maybe not really correct to call it auroral lights, because the lights themselves are not entirely responsible for the formation of the sound, and the sounds also seem to happen without the lights. But more about this in a few minutes. First, Aurora. What exactly are they, in case you didn't know, and what do we know and not know about them? Well, as you can probably imagine, this is a phenomenon that humans have been observing for thousands of years, and very likely since our origin on the planet. There are actual written reports from ancient China, from ancient Greece, from a lot of ancient cultures that didn't really understand what they were looking at, but they saw them and they marveled at their existence. But it was really in the last 200 years that we finally realized what's happening here. Here's a painting from 1865, the painting simply titled Aurora Borealis. With the discovery of the magnetic field of our planet, and the advance of technologies such as, for example, telegraphs, the scientists finally realized that all of this is electromagnetic in nature. with some of the first observations, calculations, and discoveries coming from the famous Carrington event, when the aurora were observed really far south, including cities like New York, and where the electromagnetic interference was so strong that not only did it damage certain telegraphs, but certain telegraphs were even operated without any battery by using electricity from the aurora, or to be more exact, from the charge that was formed as a result of a very powerful geomagnetic storm. Which means that the sun is responsible for all of this. And so very highly charged particles coming from our sun during certain types of storms will usually get deflected by the magnetosphere of our planet and then propelled down into the southern and the northern pole, with many of these charged particles, very often electrons, although in some cases also charged hydrogen, colliding with the upper atmosphere of our planet, and then, as a result, charging some of the atomic particles that are present in the Earth's atmosphere. And although they interact with pretty much everything in the atmosphere, it's really only the excitation of nitrogen and oxygen that produces all of the light, with the main principle being relatively simple and visible right here. When these charged particles hit either nitrogen or oxygen, they excite the molecules, which then usually stay in this excited state for at least a few seconds. Here's another way of kind of imagining it. But this excited state doesn't last very long, and after a few seconds, the energy is released as a photon, which is usually visible in a very specific frequency of light, with the color itself being formed by the different types of energy produced and the different level of excitation or the different type of molecule, and also to some extent depending on the total density of the gas present in the atmosphere. So for example, at higher altitudes, and here we're talking about above 100 kilometers above the ground, so basically in space, the concentration of atoms is really low, but it's predominantly oxygen. And here the excited atomic oxygen usually ends up emitting a lot of red light, 630 nanometers in wavelength. But it's generally only visible when the magnetic storm is very intense because of the overall low density of the atoms here. So in other words, a lot of atoms have to become excited in order for us to observe red aurora, which is why the most frequent colors and the ones that we see the most are usually green, 557 nanometers, which usually also happens at lower altitudes and is also produced by oxygen as well. But in this case, it's due to the presence of nitrogen. And it's the excited molecule of nitrogen colliding with oxygen that then transfers some of the energy to oxygen, which results in the production of green light, with pink and yellow also being produced in the same way as well, but would basically being a mix of two colors. So if we were to combine all of this, it would kind of look like this. But there's also obviously nitrogen that's involved sometimes, and this is usually something that happens at lower altitudes. And that's because at lower altitudes, molecular nitrogen takes over and becomes a lot more prominent. And here it often emits its light as either blue or red depending on the amount of energy received, and that naturally results in red, blue, but often purple aurora as well. But all of this is only possible because of the lower concentrations of oxygen and nitrogen in the upper atmosphere. Once the air density increases enough, the excitations and the release of energy as visual light becomes more or less impossible, which is also why we don't generally see these effects much closer to the ground. And by the way, by studying the aurora and understanding that density and presence of oxygen and nitrogen seems to play a big role in their formation, in theory it could become possible to remotely measure the amounts of oxygen and nitrogen in various exoplanets out there. But that's of course something that we can only do once we're able to see the colors coming from those particular planets. At the moment it's not possible. But that's just a very simple version of the aurora. By itself, the phenomenon is really complex. There are also things like proton aurora, which are usually formed by excited hydrogen. There are also some additional phenomena like flickering aurora, black aurora, or even red arcs. And even more recently discovered and very poorly understood phenomena such as STEVE, strong thermal emission velocity enhancement, discovered by citizen scientists back in 2016. Picket fence aurora, which are also visible here as well. And a phenomenon discovered only a couple of years ago known as the auroral dunes. So there are still a lot of secrets and a lot of unknown details about the phenomena, with many of them formed in a slightly different way from one another. On top of this, other types of aurora exist around other planets, for example Saturn and Jupiter, both of which produce it in a different way. And not so long ago we talked about some of the discoveries in regards to the Martian aurora, which seem to be only visible in the ultraviolet light. Which means that there are still so many unanswered questions in regards to the aurora in general. But what about those sounds? Well, first of all, the actual recording of the sounds was only made back in 2004. Here's kind of what it sounds like. with this of course serving as an official confirmation that these phenomena are real and seem to exist. But many scientists were not happy with this because it didn't really make sense. How can a visual phenomenon approximately 100 kilometers up in the air produce an audible sound that we can then hear on planet Earth? As a matter of fact, one of the first explanations back in the early 2000s was that maybe it was an illusion. Maybe it's somehow related to the phenomenon known as the McGurk effect. And that's actually a very well-known illusion where our complex brains are able to perceive sound simply from the visual observation itself. I think one of the most common examples involves making certain sounds with your mouth but not actually hearing anything, yet our brain are somehow able to hear the sound. Here's, I guess, an example. So in this case, through visual perception, we're able to sort of hear the sounds. With my favorite example being this. I mean, you can literally hear him say whoa, even though this is just a GIF that has no sound attached to it. And so these were some of the initial explanations. Maybe by looking at the aurora, which are visual, we could somehow hear the electrical buzzing or cracking that our brains were sort of interpreting as a result of visual observation. But some scientists were not happy with this, and they managed to catch the sounds in action and record them. Which presented a problem because there was still no explanation for how they were formed and why exactly the aurora were able to do this. And that's of course until the recent discovery from the same people that recorded the original sounds. It looks like it has pretty much nothing to do with aurora at all, but it does have something to do with geomagnetic interaction and with the load of magnetic field in the planet. With the recent recording of the sounds being done when there was no aurora visible in the night skies. And so here's how the scientists think it works. On a cold, clear, and relatively calm night, the atmosphere usually forms different layers. There is usually a cold layer underneath and a slightly warmer air above it. Something that happens in very low wind conditions. And this layering seems to play a really big role in the production of the sounds. The presence of cold air and warm air ends up producing different types of charges on both sides. So we'll have a lot of negative charge on one side and a lot of positive charge on the other. And because nothing is disturbed yet, the charge will start accumulating and become stronger and stronger. And this is when any kind of a geomagnetic disturbance, such as a solar storm or really anything that affects the magnetic lines of our planet, can suddenly change everything. The disturbance in these layers reconnects the charges and causes an electrical discharge, which is usually audible but not visible. And depending on the type of a discharge, will produce different types of sounds, anything from crackling to possibly even sound of a waterfall. With the most important discovery in this case being that, well, it has nothing to do with aurora whatsoever. It can happen because of any kind of a geomagnetic disturbance, which has now been confirmed and detected by the scientists behind all of this. They were even able to actively predict approximately 90% of these auroral sounds, simply measuring the geomagnetic data from our planet and not aurora. Which simply means that aurora are not responsible for the sounds, but both phenomena are more or less produced in the same way. They're produced by geomagnetic interaction of our planet with a lot of other phenomena. Which also means that we can probably now assign a slightly different name to this phenomenon, simply because they have nothing to do with aurora, and simply because they are a phenomena that happen much closer to the planet, at an altitude of anywhere between 70 to maybe 100 meters. So this is actually something we can technically even measure using physical devices. But because this is such a rare phenomenon, this is why it took so long for all of this to be measured and for all of this to be explained. Now, as you can probably imagine, it only happens in those very specific conditions: cold air, warm air, and very, very little wind. Something that we can probably only find in certain regions of the planet. And so discovering where this happens and, of course, how often this occurs would probably be the next logical step. And so once we discover more about the phenomenon, I'll make sure to follow this up in another video. Until then, thank you for watching, maybe subscribe, maybe share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Support the channel on Patreon by joining channel membership or by buying the wonderful present t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.